November 2021 math paper 1 memo. Yeah, so I actually haven't looked at this paper at all. I haven't scanned it. Nothing, boss, nothing. I know I went through question 11 the other day, but I really haven't done anything in this paper. So this is all gonna be a surpriser. But anyways, as always, this is nice and simple, straight to the point. I think these are some of the questions that you actually probably skip or something like that, but yeah, it is what it is. So on my side, yeah, I always prefer using, I know this is this is one of the easiest questions out there, but look at me using the quadratic formula. I'm starting to think it's more of an addiction, more than anything else, because this question, I don't think it's difficult, but here I am already. So I'm just gonna put this into the quadratic equation. Oh, I'm putting a plus over there. It's a minus, bro. It's a minus. Thank you. Okay, A here is a 1, C is a negative 24. And so as you're watching this now, what you can remember is that in the description, you have timestamps to the different questions and everything like that, so that you don't have to skip through on your own. So let me put all this in the calcul of the later, and I'm getting the negative 4. Let's put the x is equal to negative 4. The other one, let's see here, x is equal to 6. Nothing crazy there. The next one, oh, definitely quadratic equation. I'm like, hello. X is equal to minus b. And you're probably wondering, why do I keep always writing the quadratic formula? I guess if you're going to use it, you might as well just write it out. It's really not going to cost you ink. It's not going to cost you much. So just do it, just do it just to be nice to the examiners, to be like, yo, look, I know what I'm doing, I know what formula I'm using, and I know that this formula is going to give me the answer. So this one is definitely one where you have to use the quadratic equation, because normally when you when you're asked to round up to 2 decimal places, that's definitely a scenario where they want you to use the quadratic formula. But anyways, let me see here in the calculator. We are getting there. Let us see there. We're getting there negative 0.69. Oh, x is equal to, let's see what x is equal to over here. It's 2.19 if you round it off to 2 decimal places. Question number 4. No. It's the third question, bro. It's the third question. So here, if I have to write it out just so that it's clear, because it's yeah. So in the description, you'll also find a copy of what I'll be writing it out, of everything that I'll be writing out. You will also find a copy of the papira, the empty one. Or will you? I don't know. Oh, that's a good one, Dave. That's a really, really good one. Oh, man, bro. Yeah, you'll find a copy of the empty one as well. But anyways, let me see here. If you're going to solve this inequality, right, you got to do it properly. So you doing this properly, what you gonna do? Hey, this is difficult. Oh, it's not. Gonna take everything to one side. I feel like I'm getting distracted. You're gonna take everything to one side, né? And then after you take everything to one side, you want to realize what kind of a graph this is. This is a smiling parabola. So you are just going to draw a smiling parabola. And then since you've drawn a smiling parabola here, you want to, for you to answer this question, né, you need to know what your x-intercepts are. That's why that's why with questions like these, you solve for x first. So solving for x here, you'll have x is equal to, let's see, factors of 4. That will give you a 5. It is just, let me factorize this. Factors of 4, that will give you a 5. Now it's just 4 and 1. So you have 4 here, you have 1 over there. And then to get a plus 5, yeah, I feel like this one needs the quadratic formula. You think so too? Yeah, I think this one is the quadratic formula. Yeah, let me just use the quadratic formula, see what we get. So here x is equal to minus b plus minus let's see here, b squared minus 4. A here is a positive 1, so let's see here, 1 negative 4. So what I'm doing here, I'm getting the x-intercepts, right? Because whenever you work out questions like these, you most definitely need the x-intercepts. So but then this is, I think I wrote it down incorrectly though. Oh, when you move it over, it becomes a plus. This is so dumb, man. Whew, thank goodness. So here you're gonna get 2 x values, né? you're gonna get the negative 4 and negative 1. Okay, so x is equal to like negative 4, x is equal to negative 1. So the idea here is you want to now answer this question. This question was asking where is the graph below 0, you see. So you know that the graph is below 0 over here. You see the graph is below 0 down here. This is the part where the graph is below 0. It's below 0 from negative 4 to negative 1. So you can say here x is an element of negative 4, where negative 4 is included because of this line over there. So negative 4 you included. As long as this extra line is there, make this a square bracket. And then as long as this extra line is there, make this a square bracket as well, you see, because it's saying where is it smaller or equal to 0. It's equal to 0 at negative 4, it's equal to 0 at negative 1, but it's below 0 between those 2 points. That's the way. I like it. For 4 marks here, nothing crazy here. You're just going to square both sides. You know, questions like these, yeah, I'm pretty sure as you were like practicing for whatever it is that you were when you were studying or whatever, when you bumped into these kinds of questions, I'm like, you already know the drill, you know. Question 1, pick questions, just get your marks and I'll move on. And I know this is the strangest thing about going through a paper, you just can't stop talking. So I talk forever, man. Like, I literally talk non-stop, bruh. You wonder, most of the time when I finish these recordings, like even my voice will be telling me like, this boy, he's beat. It is beat. But let's see, this is like plus x squared, x plus 28. Let's move everything to R1 the side. Let's see what you're gonna get here. Everything on one side, you're gonna have 0 here, ne? Yeah, let me just make this smoothish. Let me not try and do too much at the same time because I'm like, but I heard. So let's see here. This is like x squared, right? X squared. And then this is like negative 4 minus 1. That's like negative 5. And this is like 4 minus 28. That's like negative 24. Nice. Just wait. I like it. Yeah, now, what else now? Oh well, it's good, eh? Oh yeah, we can just use what? I don't know, I'm thinking of using the quadratic formula as always, because like, why not? So let's see here. I'm like, yeah, I don't need to use the quadratic formula here. It's just going to be 8 and 3 if you factorize. 8 and 3 give you a 5. So what you would need to do here is you have 8 over here, and then you have 5 over here, and then you wanna 8 and 3, bro. 8 and 3, maybe, bro. Come on now, come on. Thank you. So you wanna ask yourself, to get a negative 5, you're gonna need to say negative 8 plus 3. So here you're gonna have to say x is equal to 8 or x is equal to negative 3. But with these kinds of questions, always double check your answers, because whenever something has a square root here, usually only one of them works. Like now, you see, if you put a negative 3 here, you're gonna have 2 plus 3, which is 5. If you put a negative 3 over there, you're gonna get 25. Square root of 25 is a 5. So the negative 3 looks like it's gonna work. So the 8 probably doesn't, because 8 plus that is like 30 something. But then if you put an 8 here, let's see, 8 plus 28, what is it now? Yeah, the 8 doesn't work out. It won't balance the equation. So you can just remove the 8, because these two sides won't balance if you put an 8 on both sides. 6 the marks. We are going we're about to get 6 marks for this 6 mark question. They want us to solve this simultaneously. So for 6 marks, they just said we should what should we do? We should take the 3 to the other side. Next, it's like 2y minus 3. This is equal to x. And then you can just make this equation 1. Equation 1, you're going to throw it into this equation, you see. So wherever I see x, you're going to put 2y minus 3. So this is like 2x, right? No. Where x is, you're going to put 2y minus 3. And then this is like times y. So it's best to even write the y with the 2 in the front there, you see. Because I'm like, that's the way. I like it. So the y, I've written it with the 2. The x is this value here, and then plus 7 equals to like x squared. Whoa. I need to put a value for x, bro. Don't get distracted, okay? My mind is like roaming. It's going to different places. Please come back down here. Thank you. Okay, this is squared. This question looks like it's a repeat of some other question from somewhere, you know? Like, it just looks like it, you know? Like, come on, guys. Like, y'all couldn't think of a new question? Like, hello? Hey, let's multiply inside. Let's see. This is like 4y squared minus 6y plus 7. And then this is like 2y times 2y, right? It's going to be like 4y squared. And then 2y times... let me not skip steps, you know? Because, like, why not? Why you got to skip steps for the people? This is like 2y minus 3. 2y minus 3. And then this is like 4y squared. So this is like 4y squared minus 6y plus 7. This times that is like 4y squared. This times that is like negative 6y. And then another 6y. And then plus 9. Now the big idea here is the following. You're going to have here this. If you take it over, this two are going to cancel out. So if you take everything to one side though. Whoa. Bro. Yo, negative 6 minus 6 plus the 6. That's like what? Negative 6 is going to remain. And then the 9 minus the 7 is going to be like a positive 2. 4y squared. I hope everything is on the right track here. Let me just quickly double check the what? Yeah, everything looks like it is a-okay over here. You can just put everything in standard form and then just solve for y. So this is like 4y squared minus 6y plus 2. Quadratic equation. Yeah, I won't lie, né? Let me actually admit it. And as much as I like using the quadratic equation, I'm writing it down all the time. It's like, you see now, kind of just like, you know, hey, yeah, it is what it is. So minus, but the thing is, it's safe, you know. So just stay safe, you know, stay safe. So just use it. Minus b squared, 4a is like a 4. C is like a positive 2. And then the whole thing over 4, like that. Anyways, we are good now. Let us see what is this in the calculator. Let's see here. This is gonna give us in the calculator a positive 1. Let's do that there, positive 1. And then the other one, is gonna give us a half. So these two answers, right, you're just gonna put them into your what? You're gonna put them into your original equations, bro. Like, you know, that's where you're gonna put them. The reason why you're gonna put them into it's just like 2y minus 3 is equal to x. So this is like 2y minus 3 is equal to x. And then let's see, 2 and 1 here minus 3 is equal to x. Oh, come on, man, come on. And then here x is what? Ish. Hey, you see when you don't give yourself space, né? It's sad. It's sad. I don't lie, it's sad. Why am I being so extra? X here is going to be equal to negative 1. And then for the other one, if you put a half over there, let us see what you will do. So this is like 1 minus 3. That's like negative 2. Whew. Wow, these answers look a bit... They look okay. They look okay. Why? They look fine. Moving on here, this is an interesting question. It says the following. What does it say, bro? What say it, Fraya? It says what it is saying. So let us just, So it says here. The roots of an equation are this. Where m, n, and p are positive real numbers. Yeah, this looks super familiar. I feel like they're recycling things here. Yeah, fine. It's a root of an equation. Wait, no. They said a, b, and c are positive real numbers. Okay. The numbers m, n, and p in that order form a geometric sequence. Oh, ha. Prove that x is a non-real number. Ha. This question is deep. It maybe looks deep because I'm like, a geometric sequence. Like, I thought we're doing nature of roots. Man, it's like you read it, you're like, nature of roots, and like, sequences and series. You're like, but then, wow, what's going on? Anyway, so because this forms a geometric sequence, now you want to make use of that. Because they said m, n, and p, right? So it just means n over m is the same as P over N. You see, that's what shows you that you have a geometric sequence. That's the only thing you can take away from this piece of information for now, you know. They say you should prove that x is a non-real number. If x is a non-real number, then it means you must prove that this expression is not there's no solution, you know. So luckily here, if you're going to prove that this expression is no solution, because of how nature of roots works, when you're going to prove that something is no solution and you have, like, you know, a square root symbol or anything, just prove that what is under the square root here is a negative value. Because if you can show that what's under the square root symbol is a negative, then you would have shown that there's no outcome here. You know, this thing does not give you any outcome. It will not give you any values of x, you see, because if the bottom is a negative, you have no valid solution. So let us do that. The bottom part here, it's n squared minus 4mp. You want to prove that this is below a 0. So what do we have? We have this here, we have this here. The issue is we have 3 variables, you know, and yeah, that's not very nice, you know. That's not very nice. But the good news is there's n here already. So let's see and see what we can do here. Let's cross multiply this thing. If you cross multiply here, you're gonna have n squared is equal to mp. So we might as well start there, you know. N squared, because I cross multiplied. N times n is this times that is that. So if I throw mp here, you see it's going to be mp here minus 4mp smaller than 0. Well, I mean, like, one way or the other, you want to prove that this expression is, like, you know, valid. So 1 minus 4 is like negative 3mp. They told you here that m and p in that order, they form a geometric sequence, but then they say they are positive, you see. So here, if m and p, okay, let me just do that. If m and p are positive, then negative 3mp will always be a negative. Therefore the expression, therefore x will yeah, so here you can just say therefore x is a non-real number. Therefore x is a non-real number. X is a non-real number, like that. So x being a non-real number, that is all you said. The next one is a 2-mark question here, you see. For 2 marks, it says calculate the value of x. So this is a geometric series. I mean, like, if it's a geometric series, then it just means that 81 divided by 90 is equal to 90 divided by x. Solving for x, you can just cross the multiply. This times that gives you like 81x. This times that, you know, is it like 81? Yeah, 100. So divided by 81 on both sides, your value of x is what? Is it like this looks a bit weird, because I'm like, is it 100? It is, bruh. I'm like, why am I doubting myself, man? Like, why am I doubting myself? Okay, so I'm not doubting myself or anything. I'm just like, you know, like, yeah, it's just 100. Like, really, bro, come on now. Come on. 100. There we go. Nice. 2 marks, people. We have got 2 marks over here. For 2 marks. 2 marks, it says, show that the sum of the first n terms of Sn are this. Okay. Sn is equal to 1000. There's like 1 minus, okay, let's show that the sum of the first n terms is equal to this. Oh, okay, well, this sequence is like 100, 90, blah blah blah. Why is this thing so thick now? So thick. Let's see, 81 there. Okay, fine. So with this sequence, they say the sum of, okay, so we can just use our Sn formula. I'm like, you know, don't overthink it. But the other thing is, the value of r here is just 81 over 90, you know. Yeah, so Sn, if it's a geometric series, remember Sn is like a Rn minus 1, the whole thing over R minus 1. And then A here is like 100, so it's like Sn, this is like 100. R, what is R? 81 divided by 90, 81 divided by 90. N is just like N. And then what? Just away. Okay, 81 divided by 90. Ish, I'm wondering to myself, where is this 0 point something coming from? Like, you see these people? These peoples, they're not fun. But yeah, this is crazy, eh? 1 minus, oh wait, no, let's do it the other way around. Let's use the other one. Because remember with these formulas, there's two of them. There's one that has 1 minus r at the bottom and at the top. And then there's one that has r minus 1. So let's try this one. Sn is equal to a 1 minus r to the power of n, 1 minus r. You see, it's just the same formula. These two can just be swapped around and it's still correct, It's still gonna work out. So I'm persuaded to use that because you see here there's 1 minus something over there. So I'm still thinking, why is r 0.9 though? Like, really? Is 81? Nah, fam. Wait. This is so weird though. This divided by that, okay, maybe it is, because like 90 divided by 100, that's like 0.9. Oh yeah, let's just use that then. R, yo, so thin, my brother. Come on, man. Come on, man. Do something. Thank you. So R is 0.9 because you see 90 divided by 100 is like 0.9. So A here, what is A? A is 100. Okay, oh, it makes sense now. This is satisfying. Is it? I don't know, man. Like, we but get answer. I don't know why I think this 1000 is just an error. Is it just me? It's 1000. You're not. Oh, the bottom. 1 minus 0.9 is like 0.1. Yeah, so that's where our 1000 is going to come from, you see, because this divided by the bottom gives you 1000. You see, this here divided by that, 100 divided by this gives you 1000. And then you have 1 minus 0.9 to the power of n, like that. That's the way. We like it. Okay, this is like question 2, and hence otherwise calculate the sum to infinity. So calculating the sum to infinity, nothing crazy here. I'm like, free marks galore, man. It's the free marks this, because like sum to infinity, you just have a sum to infinity formula which is on your formula sheet. A is 100, r is like 0.9, so it's like sum to infinity is equal to 100, 0.1. This is 1000. 1000. How do I know it is 1000? Because like, mental math. Question number 3. What you got for us? Question number 3. Show us what you got. Hit me with the music. Mr. Bones. If you have not watched Mr. Bones, are we even friends? Let's see. Write down the value of t number 4. Well, this is a quadratic number pattern, so I mean, like, term number 4 is not going to be very difficult to like work out, because just use what you know, just use your knowledge. So you know that this minus that, what you gonna get? Let's check in the calculator. Calculator, please tell us what we ought to know. Thank you. Like, why you gotta be so mean, calculator? Yeah, this calculator is a. Let me see here. Whoa. Wait. This is crazy. Oh, wait. So you want the first differences here, ne? And then you want to yo. Oh, you want to work backwards, actually. This is what I mean. Negative 22 minus 145. What is that, though? Negative 22 minus 145. That's going to give you like a 23. And then negative 101 minus 122. That's going to give you like a 21. So remember the second common difference is a certain value. Like this is the sequence of first differences, and then this is the second common difference, which is just a 2. So you see here, no, minus 2 actually, because 23 here minus 2 gives you 21, and then here 21 minus 2 is gonna give you let's see here, because we're working backwards, so it's gonna give you here 19. So here if you work backwards, you see this plus that gives you that, this plus that gives you that. So 101 plus 19, whoa, it's gonna give you positive 82. Thank you. This is gonna be 82. Thank you very much. Thank you, yeah. Ha ha ha. So here they want the general term, right? So if you're gonna get the general term, the general term. Oh guys, like I'm not trying to diss anyone here, but people that say R and not like R, hey, those people are fun, but it's like when you're in an argument with them, just say R and then they'll keep quiet. I feel so dumb. Just like say I mean, if let's say like you're arguing, and you see that you're about to lose, just say yeah, Shem, they'll get touched, Shem. They'll even stop fighting you. But yeah, let's see. We need to get the general term. So getting the general term, we start off with this, ne? Plus bn plus c. What you know. So, oh yeah, why did I move this to the corner so much when I actually need it? Ooh, Bosso. Come on now, bro. Nah, fam. No. Don't do that. Don't be like that, bro. Don't be like that. Excuse me. So here, this is equal to 2a. This is equal to 3a plus b. This is equal to a plus b plus c. Nice. Very nice. So getting a is quite easy over here. Let me just keep my voice. So here it's like 2a, né? It's equal to negative 2. A is equal to negative 1. And then here you're going to put a negative 1, right? So it's like negative 1 over there. Then you're going to have negative 3 here. Plus b is equal to 23. B here is going to be equal to 26. And then here, what you got? You have like negative 1. B is like 26. And then this is equal to like negative. Oh, yeah. What's going on here? What is doing you? C is what now? C is just C. So this is like plus C. This is equal to negative 145. So what you got here? This is like 25. Plus C. This is negative 145. Everything on one side, you got negative 170. Is that you? Yeah. Oh, yeah, look at that. It worked out so nicely. Like, oh my goodness. So you can say, therefore, Tn is equal to, there's like negative 1 for A there, so you can put a negative there. B is 20 to 6, and then C is negative 170. Nothing crazy, nothing crazy, people. Like, this is to prove that paper 1, guys, get that distinction, man. Get it, man. It wants you. You don't want it. Just get it. Come on now. 4 marks, it says, what is 4 marks 1? How do you get this 4 marks? So between the two terms, between which two terms of the quadratic number pattern will there be a difference of negative 121? Between which two terms? Okay, you have to realize, you see here, between these two terms, this is the difference. Between these two terms, this is the difference. Between these two terms, this is the difference. So they mean in this sequence, right? Where is negative 121? So that's quite simple. You're going to have a sequence there. It's like 23, 21, 19, going on and on. Somewhere along the lines, you have like 121. They want you to figure out the position here. You see? Let me write here position. The reason I'm writing here position is because here, you see, they said between which two terms. So you want to remember, in position number 1 is between term 1 and 2. Position number 2 is between 2 and 3. Position number 4 is between 4 and 5. So whatever position this is, we'll be able to say it is between position something and the next one. You will see what I mean just now. Let's just get this value in this sequence. Because you see, between which two terms of the quadratic number pattern will there be a difference of this much? So we said, there's a difference here between these two numbers, there's a difference here between these two, difference here between these two. If you have like gone through multiple papers on this channel, and you've gone through the course platform, like sequences and series in the sequences and series like course on the website, then this question is like pretty easy for you. So here we know that this sequence here, you have to remember it's a arithmetic sequence because it is a second common difference. You see, if this is a sequence here, this is the common difference, -2. So you knowing that, you know that Tn is equal to A plus n minus 1 d. So Tn here is like -121, n is like 23. No, A is like 23. N, we don't know, that's what we're working out. And then D, here's the common difference, so that's like -2. This is like 23, and then this is like -2n plus 2, -121. This whole thing here can take it to the, since we're working out n, let's take n to the other side, it's a plus, and then here this is like 23 plus the 2 plus the 121. What you get here, what you get? Mental math, guys, in it. Me, I don't recommend it. I recommend the calculator, me. Like, if you are going to see that, you need to work out something. Do yourself a favor and use the calculator here. So here, this is going to give me 146. Is it going to give me 146? Oh, looks like it, man. Looks like it. Divided by 2. N is like what? Is that like 83 or something? 83, 73. You see, mental math, guys, it's dangerous. It's dangerous, that thing. So n is 73. So the two terms are between 73 and 74. Because if this is term number 3, you see, it's the difference between 3 and 4. This is term number 2. It's the difference between term 2 and 3 for the quadratic number pattern. So here we can say between T73 and T74. Like that, you know, like that. 3 marks now, 3 marks now. Let's see what these 3 marks are going to do. It says what value must be added to each term in the number pattern. Okay, what value must be added to each term in the number pattern? Which term in the number pattern? Okay, this is a term going on and on and on and on. What value must be added to each term? No. This is the number pattern. Okay, yeah. What value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1. So what you want to recognize is, remember, a quadratic number pattern is just a parabola, you know? Whether it likes it or not, it's just a parabola. You see here, this is the general term of your number pattern, you see. So because this is the general term, what you want to recognize is this is drawing like a frowning graph. So this drawing a frowning graph, the way that it looks now, right, you see here drawing a frowning graph like that and like that. This is drawing a frowning graph. Now because it's drawing a frowning graph, you have to remember that this has like a maximum turning point. You see, max turning point. That's the way. I like it. Maximum turning point. So this maximum turning point, they said what value must be added to each term in the number pattern so that the value of the maximum turning point in the new number pattern will be -1. So remember, the maximum turning point here, you see, remember there's like a value for n and there's a value for Tn. So the value for Tn is the value that they are referring to, you know, because the maximum number, for it to be 1, we have to find out from the original turning point what must happen. So let's see what's the original value here, the original turning point. So the original highest value, we can get it from saying the first derivative. You see, we can get the first derivative here. So let's do this. Let's get the first derivative. This is like -2n plus 26. Because whenever they speak of maximum minimum, just differentiate and equate to 0. Works like a charm, man, you know. So let's see what n value will give us the maximum value. So n here is 13. You see, where n is a 13, that's where we'll get the maximum value for the original one. You see, so let's see what that maximum value is. T13 is like negative or what? Come on, think, bro. How? But no, man, that doesn't make any sense. I feel like I'm rushing and I'm getting lost here. It's a 3-mark question. What value must be added to each term in the number pattern so that the value of the maximum turning point of the new number pattern formed will be 1. Yona. Oh well, so I think I may have to like take a detour here, because if you're going to add a number to what must be added to each term, what must be added to each term? So it's almost like saying to each term, right, what must be added so that wow, I'm stuck. Oh, am I? Yeah, but like, bro, like, yeah, I feel like this is the first question that's like making me choke. Like, hey, like, the first question that's making me go, wait, what? Utini? Like, Utini? But then at the same time, I feel like I was on the right track though. Like, let me not overthink myself. You see what I'm just doing right now, ne? Is bad. I was overthinking. Don't overthink. When you see that you're doing something that kind of makes sense, yeah, don't overthink it. Everything that we're doing here kind of makes sense. Because look, they said what value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern will be 1. So let's see what the original value is. You see, so we got the maximum turning point to be at 13. Let's see what T13 is first and then take it from there. There's like negative 13 over there squared, and then 26 13 over there, and then negative 170. So T13, right? Let's see what T13 is. So like T13, let's put all this in the calculator and see what that comes out as. T13. Yeah, T13 is like let's see. Hi, calculator. My calculator is not functioning, guys. Let me try it again. Negative 13 squared plus 26 with 13 over there, and then minus 170. This answer is like negative 1, So what you want to know is, originally, the turning point is at negative 1. Or like, that's the highest value that the graph goes to, you see. The highest value goes to like negative 1. So obviously, if they're asking what must be added to each term, like, when they're asking what must be added to each term, you see, this is basically referring to like a shift, you see. They're basically asking you, how must you shift this graph so that it has a maximum value of 1? So if it's like having a maximum value of negative 1 to start off with, for it to end up having a maximum value of positive 1, the graph must be shifted 2 units up, you see. So let's say here, each value must have 2 added to it. You see, because if 2 is added to everything, then it means you're moving this graph 2 units upwards, and if you move it 2 units upwards, it's going to have a maximum value of positive 1. So this question, you see, no overthinking there. It was not very nice, I don't want to lie. This question is like, bleh. It's like, bleh. So when you bump into these kinds of questions, don't overthink it, don't stress yourself too much, don't think that these are the big mark questions. No. If these ones are not your cup of tea, my friend, this is what you must do. Don't stress too much about it. Finish your paper and then you can always come back to them. Don't try and figure them out if you know you still have a gang load to go. Okay, consider the linear pattern 579. This is a linear pattern, meaning it is a common difference. You see, 2 going on and on and on and on. Here is they say get T51. So T51, I mean, you don't have to worry about getting T51. I mean, like, just use your general term, like, hello. This is so nice, 3 marks. Yeah, so far so good with this paper. Yeah, it was a cake, eh? It was a cake. It was a kake. Cake. A kake. I mean, like, look at how you spell cake, dude. Like, cake, why do we have to pronounce it as cake? I feel like kake is like, it's like, I don't know, man. Kake. I promise you'll never look at the word cake the same again. It's kake. Yeah, man, I feel crazy right now. A is a 5, and then N is like 51, and then our value for D here is just a 2. Calculator, please tell us what we must do. Calculator, what is the final answer? Is 105. Thank you very much. 105 is the answer. And then there's a 2 mark question here. Calculate the sum of the first 51 terms. Wow. It was 3 marks, most. Yeah, thank you, man. Like, wow. N is 51. What was A again? A is like a 5. Yeah, what are you doing, bro? What you doing? Why are you trying to sabotage yourself now? 51 over here, and then our value for D is like what? What you get here? It just has like a positive 2. Yeah, I thought it was negative. Positive 2. And then what is next? Like, oh my goodness, let's see. The next thing is like 2,805. 2,805. Let's see. 2,805. So that's like S51. So, one more question here. Write down the expansion. Ooh, why it got chopped off here? Was this 5,000? I hope so. I think it was 5,000, man. Let me try and remember. Let me try and remember very hard because I forgot me. Yeah, but I think this is like 5,000 though. 5,000. Let me just double check somewhere quickly. Give me 2 seconds. Yes, it was 5,000. They said we should write down the expansion of this, show only the first 3 terms and the last term of the expansion. Oh, the first 3 and the last term. Okay, so remember what this means is, you have a general term over here, you see. Let me write here general term, you see. General term, oh, I zoomed in too much here. Now even writing is not nice. General term. This is your general term, you see. You're adding up values from 1. You're starting to add up numbers from 1, and then you're ending up until 5,000. Fantastic. So, because you're starting from 1 and you're adding up at like 5,000, that's obviously like, a big deal, that is a proper big deal. So, because that is happening, what you got? The first 3 terms, you're going to put 3 where n, 1 and 2 and 3 where n is. So, it's like 1, 2, and 3. Term number 3 here, you see. These are the first 3 terms. And then the last one is going to be term number 5,000, So, like, a number little chicken wing here. A number little chicken wing. I don't even know where first I had that from, A number little chicken wing. Ain't nothing but a little chicken wing. You say that when something is like super simple, Because like, who does not eat a chicken wing? Yeah, but let me not lie. Sometimes chicken wings are like not so easy to eat. Like sometimes they're like, no. Okay, but let's see. What is the first term, second term, and the third term? Let's read this question nicely before I mess up good, Yeah, I don't think I'm gonna mess up good here. Wait, write down the expansion of this. Show only the first 3 terms and the last term of the expansion. Okay, so write down the expansion of this. So writing down this expansion, right? Let me just get these numbers here. This is like 2 plus 3, that's like a 5. 4 plus 3, that's like a 7. 6 plus 3, that's like a 9. This is like 10,000. Yo, 10,000, my friend. 10,000 plus 3, that's like 10,003, bruh. So, okay, so if they want you to write this expansion, show only the first 3 terms and the last term. So it's like 5 plus 7 plus 9 ... plus 10,003. This is what your expansion is going to look like. That's why it's just a 1 mark question. Nothing crazy, nothing major. Do not overthink it. So I have written this down, and I am going to move on now because, like, why not? 4.4 says hence or otherwise calculate this plus that. Goodness, man, goodness. Ish, what number is this now? Is this 4099? I think so. Hey, I think so, bro. Like, I think it is 4099. This, like, legit. Let's check it out. 4099. So you should add this to this. Ooh, hectic, man. It's like they're fighting. What the hell, bro? What are you saying? For 4 marks, hence. But any question that starts with hence name is really annoying, because any question that starts with hence needs you to use the previous question. But then now I'm thinking, hey, how is the previous question gonna help us now? Like, I don't even wanna lie. This is like really annoying, huh? So, let's see. To be honest, name, even though hence means use the previous question, I'm so glad I'm doing this, because here I'm gonna say here in this case, I'd rather not. So the reason why, in this, so here I'm saying in this case I'd rather not use the previous question. So I'm speaking from my mind right now. You see, I'd rather not use the previous question, because just thinking of the previous question, I'm just already like confused to say, like, how are you going to use the previous question? So if that's the case, what you do is just work out your own thing, Just use the SN formula for this, use the SN formula for that, and you're done, So this is what I mean. For the first one, using the SN formula for the first thing here, you see, remember this thing here is saying that you're adding up the first 5,000 terms, starting from the first one. And then this is your general term. You see, this is something that will give you a specific number if you use the SN formula. So using the SN formula, you're working out the sum of the first 5,000 terms. You have, remember, it's like n over 2. And then this is like 2a plus n minus 1 d. And then n is like 5,000. And then your value of a, what is your value of a? The first term here is like a 5. So it's like 2 with a 5 over there. There's like a 5 minus 1 over there. What's your value for d? Your value for d is a 2. Okay, let's put everything. You're gonna have to put, you can put everything in the calculator, that's fine. So here now you're gonna have s well, let's do the other one. The other one here, it's like you're working out the sum of the first 4,999 terms, you see, starting from where n is a 1, and then this is your general term, negative 2 n minus 1. Okay, why did I put a 5 here and a 5 there? Bro, come on, man, it's 5,000, my guy. How you replace 5,000 with 5 now? What is that? You anyways, in the previous question, what we found out that the difference here is just a 2. You see, 2. That's why I put a d as a 2 here. Just go back here, put this 5,000 here, 5,000, and then n is also 5,000. What is d gonna be? D is like a 2. Okay, let me go back here. So here we can just get the answer, you can just use your calculator just now. Here, I mean, what you want to recognize is this is your general term, so you can use it to get a, and you can use it to get d. So remember, a is like the first term, so let's put a 1 over here. Let's actually get the first and the second term so that we can also use that to get d. So let's do that. Oh no, I'm running out of space, man. So negative 2 minus 1, that's like negative 3. And then negative 4 here minus 1, that's like negative 5, So your value of d, you would have said t2 minus t1. So that's like t2 minus t1. So that's like t2 minus t1. Negative 5 plus 3, that's like a negative 2. Yeah. Okay, so you have a d here. D is equal to negative 2. And then a is equal to negative 3. Perfect. Okay. So let's get this answer. Let's do one for that one as well, I feel like I'm running out of space over here. Let's do that. What is next? Okay, SN formula. S how many here? S 4099 is equal to 4099 over 2, and then this is like 2 times 4099. This is like plus 4000, and oh bro, why you all this space and you're busy in the corner there? You though. You disappointing me, you. So let's see. 4 what is this now? It's like 4000 what. So let me close this thing here. 4999 minus 1. What is your value of D now? Your value of D is like a -2. There you go. So we're gonna put the green in the calculator. We're gonna put the yellow in the calculator as well. So let's do it. So it's like 4. Snap. Gonna put everything in the calculator now. So putting all these two in the calculator, what do we have over there? Yeah, we got some quite interesting. Oh, hey calculator, please help us. So let's see. I need to clear this calculator first. So I think let me just pause and then put the stuff in the calculator. Anyways, welcome back. I have got the 2 answers here. This is for the yellow one. This is for the green one. So I'm like, you can just add up those 2 together, and then you will get the final answer. So let's see. Why didn't I just add them up? You see now? No. So let's see here. Final answer. Let me put it in red. You're gonna add these 2 up, ne? So let's see here. This, you're gonna add them up. You see this here. Gonna add that there, because that's what this is telling you to do. It's telling you to add them up. So if you're gonna add these 2 up, I hope, I think everything looks okay here. If you're gonna add those up, it's gonna be equal to 4999. This plus that is gonna give you it's like 9999. Yeah. So obviously whatever I'm gonna write down, if anything looks funky or fishy or whatever, just hit me up. Hit me up on IG. My IG is like LE_EVY. There we go. And then there's a 50% coupon code for the courses on the website, because you're watching this video. You rock. Yo bro, calm down, brother. Anyways, let's see here. 2 more questions. This 2 more question says the following. Write down the equations of the asymptotes of f. Write down the equations of the asymptotes of f. Well, remember this down here, you're going to have your asymptote, which is going to be a +3. This here is also going to give you an asymptote, which is going to be a +2. So the x asymptote comes from here. You always take the opposite of this number. So x is equal to +3. Because this is already in standard form. You see, f of x is equal to ax minus p plus q. And then, so here y, you're going to have y is equal to 2. That's your other asymptote. Because this is going to give you the y asymptote. And then this is going to give you the x asymptote. Excuse me for being so extra. I don't know. The domain. So the domain, you always say x is an element of R, but you exclude the asymptote, X is an element of R, but then x is not equal to the asymptote, because your graph can go anywhere except for where x is a 3. Because guess what? This is a hyperbola. Or 2 more marks again. Determine the coordinates of the x-intercept of f. Wow, man. This is just like... some of these papers, it's like, okay, thank you for the free marks, So take advantage of it, because the one thing that I think we can all safely say is your prelims are kind of difficult-ish, because they are there to kind of wake you up. And then your finals, they're just standard, and this is just proof of that. So got all the proof you need over here. So if you're going to get an x-intercept, right? Remember, an x-intercept, you have to make y as 0. So the 2 can go over. That's going to be like a -2. This is like x minus 3. Then this is like over 1, right? So because you want to make x the subject of the formula, you can just cross multiply. This is like -1. This is going to give you -2, x minus 3. Then this is like -2x plus 6. This is like 1. The 2x goes to the other side. The 1 comes over. Really? X is a fraction? Nah, I don't like fractions, me. X is going to be equal to 5/2. But let me not skip steps. Why are you skipping steps, my bro? Who told me you do that? This is going to be 5 equal to 2x. Divided by 2 on both sides. X is going to be equal to 5/2. Okay. Let's see here. Where is that thing? Where is that thing now? Oh, you have to give a coordinate. The x value here is 5/2. So therefore 5/2 coordinate 0. What else now? For 2 marks here, it says write down the coordinates of the y-intercept. Wow, man. These guys were just giving away marks, eh? Why am I sounding so... Like, just be happy, man. Like, be like, yeah, okay, thank you. So, obviously, here, if you're going to get the y-intercept, it means you now have to make x a 0. So, you can already see this is just like standard questions, just to see if you know your stuff. So, this is like a third as a positive, because this divided by that gives you a positive a third. And then this is going to give you like 7/3. That's the way. I like it. So you have to give it as a coordinate, you see. Y is a 0. X is a 0. Y is this. We love to see it. Lastly, sketching. Very simple stuff. When you're going to be sketching, the good news is you already have everything. So 2.5 here. This is roughly like 2.5, you see. Now, what is 7/3? 7/3 is like 2 point something. Yeah, like 2 point like 2.3, I think, if I'm not mistaken. Yeah, it's around 2.3, just somewhere there. 2.3. Wait. Is it 2.3? Let me see here. Let me just check my x-intercept again, because my x-intercept is looking a bit weird there. -1 is gonna be like that. And then what, man? What you get there? I'm a rock star. Play me like a guitar. Man, I am just like, just vibes, man. Just vibes. So let me just double check. I'm just double checking my answer here so that I don't end up, doing something silly. Yeah, I forgot the -1. So excuse me over there. I think you spotted it, because you've got good eyes. So this is gonna be a plus, and then this is gonna be a 7/2. Hooey! The boy was about to make a mistake, eh? So this is like 3/3.5. Just change that. Excuse me. Just wait. I like it. So let's put our asymptotes. When you're going to be sketching a cube hyperbola, always put your asymptotes first, and then put whatever you can put there. Let's see. Come on, can't I straighten it? Thank you. Wow, man, so nice and so fancy. Let me see if I can straighten this one. Make it straight, please. Ooh, fancy. Oh well. So let's see. What is... This is like, we have to put the asymptotes 3 and 2, right? So it's like 1, 2, 3. So it's like 3 here. X is a 3, so you do this over there. 1 and 2, so it's like this here, and you do this over there. And then what you get, the graph, you have to remember that with the hyperbola, you always have to look at the equation that you're given, because your equation always gives you an idea of where your shapes should go. If it's a minus, then this is how you do it, you see. Going upwards, remember, it's a plus. Going downwards, it's a minus. Going to the right, remember, it's a plus. Going to the left is a minus. So depending on what your a value is, if your a value is a negative like that, then one of your shapes will be in here. The reason why one of your shapes will be in here is because you see there's a minus here and a plus going upwards. So a plus and a minus give you a minus. That's why you have a shape in there. And then here you have a minus and a plus over there. So your other shape is going to be over there, you see. There you go. If A was a positive number, you would have put it over here and you'd have put it over there as well. Because you see plus and plus, so you'd have a shape here. Minus and minus, so you'd have a shape in there. So here we just need to get these. We just need to put in the intercepts that we worked out. Because remember the y-intercept was like 3 point something. No, it was like 2 point something. No, 3 point something. I mean 2.3. The x-intercept was like, was it like 3.5? Yeah, this was like 3.5. This is like a 3. What is the y value here? A 2. There we go, man. There we go. Anyways, everything looks all nice and dandy over here. Nothing major, nothing crazy. Let me just do this, do that. What else mask can do? I actually don't know. No, let's do this. And do this. Whew, okay. 6 marks, right? I mean, question 6 is the next one. Oh, yeah, you can see there's the graph. No, all good. Question 6 says the graph of f of x is equal to log 4x. Okay, log 4x. And then it says here B is a point on f. And then there's a 2-mark question asking us to calculate k. So k is the x value. So, I mean, like, that's quite simple. F of x is equal to log 4x. So this is like log. There's a 4 here. There's an x over there. And then k is x, right? So k is x and then y is 2. So this is like 2 log with the 4 and then this is like k. And then let's see. What you got? So this is like base and then an exponent. You see, this is a value on its own. You see, base, exponent, value on its own. Base is 4, exponent is 2, value on its own. You see. So here k is equal to 16. Don't forget it, you see. You always have an exponent here equal to the log. The base will be the value down here. And then you'll have a value on its own there, you see. This, when you restructure it, this is how you do it, you see. As we have written it here, you see. This is the base and the exponent. So you'll have at the end here a base with an exponent. And then this will be equal to a value, which is what we did over here. So 2 marks here. Determine the values of x for which this is between -1 and +2. That's not a difficult question. This is asking you where are your y values between -1 and +2. So I mean, like, you just want to work out, let's see here, right? Let's see, where is -1? -1 here is like somewhere here, ne? So let's do that. Let's put like -1 over here. -1. Let's do this, 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 do this. This is -1, right? And then +2 is like somewhere over there. So it's like, oh no, there. this. Let's do it. Okay, they said, for which values of x will this be between -1 and +2? So, I mean, like, we can see that just because of the way this is, like, you know, structured. We can see that the first x value is a 0, you know, starting from, you see this graph here. No, bro, come on, no. Somewhere here is like where y is a -1, you see. So we don't know what the x value is over there. We need to find out, you see. And then somewhere here, we know that the y value is a 2. And then we already know that the x value is a +16. So the graph is between -1 and +2, where x is between this value over here and this value over there. So let's find the x value here, where y is a -1. So you have to put a -1 in the equation of your graph there. So in the equation of your graph, let's see, this is like -1 log with a 4 and a k. So this is base to the power of an exponent. Base exponent, this is k. You've got a quarter here, this is k. So you're gonna need to say that no, bro. We got k to be 16, bro. Why are we still working out 16? You're not. This is crazy, man. No, this is x, bruh. How? I'm basically getting confused here. Base exponent, this is x, this is x. So x is a quarter, you see. So this value here is a quarter. Maybe. Tango. So x is between a quarter and a 16. So because this is included, we're going to need to say x is an element of a quarter until 16. You see, like that. And then you're good, and then you're good. So let's see, 6.3. We have to move on. Let's keep moving forward. Let's do this. What do you have to do here? Write down the equation of the asymptote of the inverse of f in the form y is equal to something. So initially you see f of x is log 4 with x. You see, initially, remember f of x here refers to y. So this is what it looks like originally. When you're going to perform inverse, you have to make x become y. And then y, you have to make it become x, you see. So this being done, you're going to have here x is equal to log 4 with a y. Now with all that, let's see here, you're going to get, what you're going to get? You need to make y the subject of the formula. So this is base and then exponent. So it's like base, exponent, this is y. So they said you should write it in the form y, but this is 100% fine, but let's just write y first, 2 marks later here, it says, what did it say? It says, for which values of x will this multiplied by that be smaller than 0? So yeah, you have to be careful here. This is basically saying where will x multiplied by this be a negative number? Yeah, it's kind of tricky. See, this will be a negative number if the first one is a plus while the other one is a minus, or where this is a minus while this one is a plus. You see, these are the only two scenarios that will make this a negative number. So what you want to remember is, firstly, just looking at it, and you knowing your work, 4 to the power of x will never be negative, will never be negative. The reason why this will never be negative is because you can never put a value here that will cause this thing here to be a negative value. See, whatever x value you'll put, 4 to the power of x will never be a negative. So it means that this scenario up here, the first one, will never happen. So what we already know is that this will always be a positive. Fine. So since this one will always be a positive, right, your expression the whole thing here will be smaller than 0 wherever x is a minus, because as long as x is a minus, you'll be saying a minus times a plus, which will always give you a negative number. So here we can just say x needs to be smaller than 0, because as long as x is a negative value, you will always be getting a negative value as an answer for your expression over there. Now obviously, as you can see, if this question is not your cup of tea, then don't find yourself doing any funny business, like don't find yourself getting confused and all that shandies. So here we just said x is smaller than 0. Like, x has to be smaller than 0. If x is a positive number, then the whole thing will be a plus times a plus. So this is your only answer. X has to be smaller than 0. They'll give you 2 marks for that. You know what I'm saying? But anyways, let us move on with this question. Let us move on with this question. So let's see. It says, no, we'll move on to question number 7 now. Anyways, Question 7 is where we at now. More functions. We love to see it tossed away. Like. I feel like I sound like an idiot whenever I sing that song. But it says question 7, the graph of f of x. This is a parabola. So because there's like a positive 4 here, it means that this is technically negative 4. Because there's a negative 6 there, this is technically positive 6. They say this parabola cuts the x-axis at B. So there's a B over there. And it also cuts it at D. And the y-axis at G. And then they said here C is the turning point of F. C is the turning point of F. And then they said here line AE has an angle of inclination of theta. Okay, so AE, this has an angle of inclination of theta. Furthermore, it cuts the x-axis. No, AE has an angle of inclination of theta and cuts the x-axis and y-axis at A. So this is cutting at A, this is cutting at E. And then it says here T is a point on F. Where is T? T is a point on F, between B and G. So this thing of saying between B and G, that one is kind of weird. Like, what you want to say now? Like, just be clear. But we'll see. For 2 marks, it says write down the coordinates of B and D. So we already said that B here is going to be -4, coordinate 0. And then we already said here that D is going to be 6, coordinate 0. The reason for that is you have to remember this is already factorized for you. So you're going to make this equal to 0 individually. And you're going to get your 2x intercepts. Okay. Coordinates of C for 2 marks. How? That's the turning point, Moose. So let me show you how to get the turning point in another way. The turning point is always the value that's exactly in the middle of this and that, exactly in the middle. So what you can already do is, since you already have your equation, just find the x value in the middle here. Just find the x value of the turning point by finding the middle of -4 and 6. So -4 plus 6 divided by 2. Let's see what that's going to give you. That's like what? -4 plus 6. What is -4 plus 6 now? -4 plus 6 is like a 2. So the x value of the turning point here is like a +1. So if the x value of the turning point is like a +1, its y value, you can just get it by putting 1 into the equation. So let's see here. In the equation of f of x, you're going to put a 1 over there. And then you're going to put a 1 over there. So it's like, 5 times -5. Ooh, really? Wow, this is crazy though. Like what? 5 times -5. -25. It seems so low, bruh. So far down there. Yeah, but it looks like that's the one, like we can't argue too much with these kinds of things, It's like, -25, my guy. So therefore C is just +1, coordinate -25. Okay. Fantastic. Let's see here. This, you're going to close it. What you do. The next one here, for 1 mark, right, says write down the range of f. The range of f. Well, this graph is like from -25 going upwards. That's the range, you see. Y has to be bigger or equal to -25. If you said y is an element of -25 to +infinity, that's still fine. 1 mark here, it's saying, given that theta is this value and the tangent of f at t is perpendicular to AE. Okay, the tangent at f is perpendicular to AE. Oh, okay, so, like, you see these kinds of things, ne? Trust me, you want to draw them out, because, if you don't draw them out, they're going to be stuck in your head. So this is a line. It's a straight line over there. Wait, it's a straight line. Oh, no, bro, come on. Straight line over there. straight line over come on, man. Ish, this is hard, eh? This is a tangent, ne? Yo, goodness, come on, bro. Tangent, eh? This is a tangent. It is perpendicular to this. Okay, fine. Moving on. They say then here, calculate the gradient of AE correct to 2 decimal places for 1 mark only. Well, I mean, they gave us theta here to be, what did they give us our value of theta to be now? What is the value of theta? It's like 14.04, right? So let's see here, 14.04. How? Well, 10 formula. 10 theta is equal to m. So if it's like 10, 14.04, your gradient over there for AE specifically is going to be 0.25. 0.25 maybe. That's the gradient of AE, because this is the angle of inclination. You have gradient of AE. You could easily use that to get the gradient of, this line here passing through T. So it looks like that's why they're asking us for the coordinate of T here, because you see T is the tangent, is the point here that is a tangent to, is the point of contact between the curve and the tangent. So what we know is, if you're going to get the coordinates of T, I would start off by, making use of our equation here, because what you know is, remember, them having to have spoken about a tangent here and you needing the coordinates of T here, just get the point of contact between this tangent and this curve, you see. So it's easier for you to get the equation of the tangent first. The equation of the tangent is just a straight line. Y is equal to mx plus c. The gradient of the tangent, you can get it from this if you use this formula. You see, m1 times m2 is equal to negative 1. This is like 0.25. This is like m2. So if you divide both sides by 0.5, you're going to have m2 here. This is like what? What is negative 1 divided by 0.25? So it's like negative 1 here divided by 0.25. This is like a negative 4, right? You're going to get a negative 4 over there. You see, negative 4. What else? What you got? So here it's like, therefore y is equal to negative 4 x plus c. For you to get the y-intercept, we don't know, eh? Yeah, you don't know. But we can, bro, come on. We don't need this. We don't need this equation, actually. We only need the gradient. The reason why we only need the gradient is because if you know what the gradient is at this point here, you see the gradient here is like negative 4. So just use that gradient to find the point of contact using your curve. You see, you don't have to equate the two equations. So you see, on the fly, you can always change your mind as long as you see that it's like making sense and it's practical or whatever, Don't just carry on and just do things that are just crazy. Because here, getting the y-intercept, we're not going to get it anyway. So, yeah. Let's see. So in f of x, for us to find out where is the gradient equal to negative 4, because remember the gradient of a tangent is equal to the gradient of the curve at the point of intersection. So that being said, x times x here is like x squared. This times that is like negative x. This times that is like positive 4x. This times that is like negative 24. This is like x squared. Negative 6 plus 4, that's like a negative 2. And then what do you have here? Let us do what? What you're going to need to do here? You're going to have to make the gradient equal to negative 4. So you're going to differentiate here to get the gradient equation. After differentiated, you're going to find out where is the gradient equal to negative 4. So this is, you're going to need to solve for x here. Negative 4 plus 2. And then this is like negative 2 is equal to 2x. X is equal to negative 1. Okay. It's all good. It looks like everybody's happy. The x value here is a negative 1. So if you know that the x value here is, there is a negative 1, You can always put -1 in the equation of your graph, and then you can do the things, you know what I'm saying? So let's see, -1 plus that, this is like a 3, -1 plus 4, just like a 3. Then it's like -7 over there, and then -21. Let's see. 7.3 says, 7.5 says, a straight line G. Oh, whoa, bro, you just got 21. Yeah. What did I even finish? Very me. I put an x value here, and then I got a y value of 21. Okay, so therefore t is like -1 is the x value, the y value is -21, because you see it even is kind of making sense, because this down here is like -25, so they could easily be -21, you see, because this is not to scale anyways, you know what I'm saying? So anyways, let us move on to the next question. 7.5 says a straight line G parallel to AE cuts F at this point, and it cuts F at this point K, and it also cuts R. Wait, I have to read this slowly, man. A straight line G parallel to AE, right, cuts K and R. Where is R? Is there R somewhere here? You see, ma'am, there's no K, there's no R, there's nothing here. So if there's, they spoke of R and K right now. I mean, like, there's no R nowhere, there's no K anywhere, but we have K, they gave it to us, but it's parallel to AE. So the dumbest thing with these kinds of questions is, unless I'm missing R, where is R? They never spoke about R anyway here. You know, that's the annoying thing. Hey, yeah, ne? Hey, mathematics. Hey, Luena Joe. Luena Joe, you're asking for too. Oh, I want you to calculate the coordinates of R. Hey. Well, G is parallel to AE. Let's just see here. If G is a straight line, it means that G is equal to mx plus c. Furthermore, if G is parallel to AE, it means that it has the same gradient as AE. Before you even worry about R, I mean, like, let's just get the equation of G by using this formula. Y minus y1 is equal to m, and then x minus x1. Now, what we know is y here represents a y value that the graph passes through, so it's like -9, I mean. And then gradient, what is gradient here? 0.25. And then what is the x value here? It's like -3. There you go. So this is like y plus 9. And then this is like x plus 3. So this is like 0.25x. What is 3 plus? Oh, 0.5 times 3. Now that's like 0.25 times 3. So that's like 0.75. And then here you have like y plus 9. Solving for y here, y is gonna be equal to 0.25x. 0.75 minus the 9. Minus the 9. You're gonna get -8.25. -8.25. Okay, so this is your equation of G. Then they said here it is parallel to AE and it cuts K. It cuts F at K and R. Oh, so what they mean is, this is just like a random line. You know, it's just parallel to AE. It's parallel to AE. It has the y-intercept -8.25. So if it has a negative y-intercept, it could be like somewhere here. So this is what the graph of G looks like. You see, it's just a random graph somewhere. So this graph here could potentially be G of x. It's just a rough sketch. So they are saying it's cutting the graph at K and R. So you can already see one of these points is K, the other one is R. For now, let's just try and see which one could be A, which one could be R. There's a negative here, so this one is definitely going to be K. So r is the one somewhere here, you know, whether it's there, the r, it really doesn't matter for now. Let's just get r. To get r, you can see that it's just a point where f meets g. So let's equate f and g to get k. So g of x here is equal to a quarter. That's what this is. Why am I using decimals, or why am I using fractions all of a sudden? You're gonna confuse the people. To be honest, I don't think I am, because I mean, like, I actually usually prefer using fractions. So yeah, let's do it. So this is like I just rewrote the fractions, I mean the decimals as fractions, you know. And then here, what is f of x? F of x, when we FOILed everything out, when was it? It was here somewhere. This is what f of x is, you see. So let's just copy this, and then let's just delete this. Delete. This is like paste. So let's equate the two together. So if you're gonna make the two equal to each other, this is what you're gonna do. You're gonna have to say g of x, man. G of x equal to f of x. G of x is equal to f of x. Okay. G is like a quarter minus whatever. Quarter minus 33 over 4. F of x is like this here, you see. X squared minus 2x minus 24. And then what you got next? You need to solve for x here. Solving for x, you can put everything on one side. You're going to have 0 is equal to like x squared minus 2x minus a quarter x. And then you're going to have like negative 24 plus 33 over 4. So you're solving for x to see whether these two graphs meet each other. You're going to have two coordinates, you see, k and r. So this minus that, what you get, man? What you get? Being weird now. Like point blank, just being weird, bruh. Like, my guy. Nah, fam. So then here, negative 24 plus 33 over 4. Negative 24 plus 33 over 4. What is that going to give you? That's like negative 63 over 4. Negative 63 over 4. Negative 63 over 4. Okay, so let's just use the quadratic formula here. Minus b plus minus b squared minus 4ac over 2a. 9 over 4. What is b? B is like 9 over 4 squared minus 4. A is like 1. Negative 63, 4 here. What is the whole thing here? What is A now? A is like a 1. Okay, let's see. Gonna need to get, what do we need to get? Hey, gonna need to get the answers from the calculator here. Because if this calculator don't give us the answers, we're not going to be happy, eh? We're not going to be very happy at all, like, you know. Anyways, let's see here. Looks all nice and dandy. The x value here that we're getting, we're going to get x is equal to negative 3 as predicted, because I'm like k has an x value of negative 3. The other one, let's see what the calculator is doing, is giving us 21 over 4. So obviously this one is the one that gave us k, because remember k, you see x value is a negative 3, the other one is a negative 9. So for r, we can just take the equation of g, throw in the y value, the x value 21 over 4. So let's see here. Let me put an r over there. So here in this equation, where y is, where x is, we're going to put 21 over 4. This is like 21 over 4. A quarter over there, 21 over 4. And then this is like 33 over 4. This is like 21 over 16. 33 over 4. What is this now? So let's see what this gives us in the calculator. So in the calculator, this is giving us negative 111 over 16. Negative 111 over 16. There we go, there we go, there we go. So question 8 now is what we need to do next. Question number 8, people. Question number 8. A farmer bought a tractor for 980,000. Okay, the value of the tractor depreciates annually at a rate of 9.2% per annum on the reducing balance method. Then he says you calculate the book value of the tractor after 7 years. This is pretty straightforward, bro. I mean, like reducing balance, original price, that's a P. The interest rate here is per annum, so that's like I, nothing crazy with this question. It's just free marks everywhere, just free marks, just free marks. So reducing balance is just your P formula with the negative. How much is the truck after 7 years? Like, wow, man, they just want to give us free marks here, which is nice, I guess. So I always write the percentage symbol so that I don't have to write it as a decimal or as a fraction or whatever. So here it is in the calculator. Let us see what we're getting over here. Is 498,685.82. Okay, so for 4 marks here, it says here, how many years will it take for an amount of 75,000 to accrue to this much? So it has to go from here to that. This is like increase. Yeah, can't they just use simple words? You see, it's gonna confuse another children here. Accrue, like what? What does accrue mean? Hey, yeah, increase. Increase. So let's see. In an account earning interest at this much per annum, compounded quarterly. So compounded quarterly means you have to say 6.8% over 4. And then you have to say that this is an amount to start off, right? P is like 75,000. And then to end off, it is like 116,253.5. Okay, so it's like A is equal to P1 plus I to the power of N. And then here, it's like 116,253.5. And then this is like 75,000. Interest is like 6.8% over 2. No, 4, bro. It's over 4. It's over 4. And there it is. Okay, we need to work out what now? How? Oh, we need to work out N. Yo, it's so weird. So working out N here, I mean, I would rather actually just isolate everything and actually just put it into the calculator afterwards. So I'm gonna remove this and actually, put my money where my mouth is. So I'm gonna divide by P on both sides first, and then this is what you have. Because you want to isolate N, right? N is an exponent, so you isolate it, then you're gonna say log. The base of the exponent becomes the base of the log. Whatever this value is the value that was on the other side, you see. So here, this is gonna be log 1 plus the interest, we said 6.8% per annum. And then this is like A. What is A? It's like 116,253.5. What is your value of P? P is like 75,000. 75,000. And then this is N. Oh well, so the reason for doing all this is so that your answer can be as accurate as possible, This is giving you an N value of like 25.99, which is going to be equal to 26 years, or, approximately. You see, so approximately, you can do like a funny squiggly thing over here, I mean, if you don't, it's really not an issue, but, if you can, might as well, show that you know your stuff, eh? Anyways, let's see. Tabo. Ach, Tabo. Unjani Tabo. What's happening? Excuse me. Tabo wanted to save 450,000 as a deposit to buy a house on 30 June 2018. Then he says he deposited a fixed amount of money at the end of every month into an account earning interest at 8.35% per annum compounded monthly. His first deposit was made 31 July 2013. And his 60th deposit on the 30th of June 2018. Calculate the amount he deposited monthly. Sure, this question, it looks so familiar though, But let's see here. So he wants to end up with this much. So this is what he wants to end up with at the end of the day. So he's making fixed deposits. So we don't know what the fixed deposits are. But then your value of this is saying saving money, earning interest at this much. So the interest rate is 8.35% compounded monthly. His first deposit is made on the 31st of July. So at the end of July, right? This is his first deposit in 2013, you see. 2013. And his 60th deposit on this date. So we don't have to worry about how many deposits because they are really telling us already, It's just 60 deposits. So I mean, like, don't overthink it. They gave you the number of deposits, So just use NS60. Don't overthink it. So here, all this being given, they want us to get x. So f is equal to x 1 plus I to the power of n minus 1. And then f here, let's see. F, x is what? X is like, no, you have to isolate x here. So isolating x can multiply by I on both sides. This is like fi is equal to x 1 plus I minus 1. Divide both sides by the big bracket. You're going to have here fi, the whole thing over 1 plus I to the power of n minus 1. This is x. Okay, so your value of x here is going to be equal to f, right, is 450,000. Your value of interest is going to be like, what is interest again? 8.35% over 12. And then what is this now? 1 plus interest. Interest is like 8.35 over 12. N is like 60. There you go. Okay, all this in the calculator. Let us see. 6,068.69. 6,068.69. Very nice. Very nice. Nothing crazy here. Nothing major. Let us move on. Tabo bought a house costing 1,500,000 and used his savings as the deposit. He obtained a home loan for the balance of the purchase price at an interest rate of 12% per annum compounded monthly over 25 years. He made his first installment of this much towards the loan on 31 July 2018. Okay, what is the outstanding balance on the loan on the 30th of June 2039, 21 years after the loan was granted? Well, did this like match up? Let's see. Oh, okay, so here by June he was done gathering his deposit, ne? And then by July he now had money and he was now like paying for his loan. So because this is a 3-mark question, I don't think that this question is like extravagant or it has like special things or whatever. No. Here, outstanding balance on a loan. Remember, the balance on any loan is always A minus F, where A is the compound interest formula, F is the future value formula. So your balance in this case is going to be equal to P 1 plus I to the power of n minus X here, 1 plus I to the power of n minus 1, the whole thing over I. And then what you got? P here. What is P? P is like what is P now? Remember, P is your loan, the one that you got. So we have to find out how much loan did he get. So it's like 1,500,000 minus 450,000. you see. So already his loan amount is just like, 1,000,000 and 50,000. Like, bro, what is going on? No, I wrote the wrong number here. 450,000. 400. No, I didn't, bro. Ish, you know what? In mental math, I'm going to not use it. Otherwise, I'm gonna embarrass myself. Like, I'm really not in the mood to embarrass myself right now. So, grabs the calculator. Minus 450,000. This is like 1,050,000. 1,050,000. There we go. Okay, that's how much you got as a loan. So that's what P is. 1,050,000. So this 1,050,000, right? Your interest, they said it is 12% per annum compounded monthly. So it's like 12% per annum compounded monthly. And then they said here, what is his outstanding balance on the loan on June 2039, 21 years later. So don't overthink it, If it's 21 years later, then you have to keep in mind that it just means that your value for your, what is this? For your N, it is just gonna be 21 times 12, 21 times 12. So let's see here, 21 times 12. That's like 252. 252. And then X is your installment, right? Your installment is like 11,000 and something. 11,058.85. And then what is interest? Interest is the 12% per annum compounded monthly. And then there's like 252 minus 1. Let's put the whole thing over 12% over 12. And now let's put everything in the calculator. You need to pause here and think and put it in the calculator. Okay, in the calculator, we're getting a... Hey, it looks okay, Like, it looks like an okay answer. I mean, like, can't be fighting with the answer. But it is weird, How is this like A and A? I feel like I made a mistake here. Or maybe they meant B here, But let's see. So for this answer, we're getting the what are we getting, bro? It is like 41,994. 41,994 point what now? Let's see what it is. 41,994. No, man, it's 400. Bro, how do you read it? It's 419,000, bruh. Joe, but he owes so much after so many years, though. Aye, man, this doesn't look right. Let me check this thing in the calculator again. Okay, so in the calculator, we're getting like, it's a biggish number. It's just showing that this was like, a very, very terrible buy. Like, how do you still owe so much after so many years, though? Hi, yeah, ne? So it's like 419,952.39. You see, this is what I'm getting. So, yeah, man, let us just move on. The next one says for 3 marks, right? Calculate what you need to calculate here. Calculate the interest that calculate the interest Tabo will have paid over the first 21 years on the loan. So the interest that he would have paid, remember, the interest on a loan, there is a formula to it, Let me say that again. The interest on a loan, there is a formula to it. The formula is always going to be your number of payments minus the amount you have paid off, So let me say that again. Your interest, or rather, let me just pause and then I can write down the formula. Let me just get it somewhere quickly. Okay, so I've got the formula. This is the formula. And it's also on the course platform, if I remember correctly. Your interest will always be equal to installments, right, minus the loan minus the balance. Keep in mind where I've put the brackets, because that's like important. We have the balance already, we have the loan already, we just need to know how many installments have been made after 21 years. So it's like 21 times the number of installments. Well, how many? I mean 21 times the amount of the installments. It's like 11,058.85. So let's see what this is. This is like 21 times 11,058.85. This is like 232,000 whatever. Okay, so this is like 232,235.85, right? Let's see here, 0.85. And then what you got next? They then, so you have installments here, you have the loan, you have the balance. Let's get the interest. You see, interest. What is installments? It's like 232 and then 235.85. The loan, how much loan did he get? The loan that he got was 1,050,000. And then his balance was 400 and something after 21 years. So it's like 419 and then 952 here. There you go. Let's see what the interest is. Interest. Check it out in the calculator. Wait, I forgot to put the decimals. This is 0.39. So let me close this here. 0.39. Yeah, let me just put all this into the calculator and then I will, we'll carry on. Let us do it. So I think I can be putting it while I'm talking, right? I mean, I feel like you could just fast forward but you're probably thinking to yourself, but bro, why didn't you just like pause the video or like just cut it or something? I don't know, man. Maybe I just want to talk to you, man. What if I just want to talk to you while I put in the things in the calculator? Why you gotta be so mean? Huh? I know I sound crazy right now because I'm talking and there's no one here. But listen, I know you're listening to me, you see, so I'm technically talking to you. So don't think I'm crazy. I'm actually, it's like I'm talking in the future right now, huh? How dope is that? Anyways, the final answer here, this value, me, I don't align, this value looks too big. Like, this value looks way too big, but like, what? It's like, no, man. Like, the thing is, it just doesn't make any sense, this value. But I trust it, me. I trust my answers, ma'am. I trust my answers, me. Let me just double check I didn't make any silly mistakes, okay? 1,000,000 and that. Let's see. Let me just make sure I didn't make any fun. Yeah, 1,000,000. Oh, yeah, I did make a mistake. I didn't put enough zeros. Yeah, let's do that. Yeah, it's 1,050,000, right? Yeah, 1,050,000. Yeah, so let's see. Yo, hi, man. Hey, let me pause because it's not working this. Oh, I get my error. Snap, man. It's 21 years, so I have to times this by 12. You see, because it's like 12 months over 21 years. So this number is much bigger. Thank goodness. I'm pretty sure you probably spotted it somehow earlier, but yeah, I'm not gonna cut this out so that you can also see, that dumb errors happen all the time. So keep a lookout for them. So that 200 and something thousand, let's just multiply it by 12. Let's see, 12 times 21 times 110 58.85. Right, this is like a big number. It's like 2,786,000 2,786,830.2. Whew, okay, I guess this is gonna be a bit better. 2786830.2. Let's now put this into the calculator. You see, I think I was busy talking too much there. Busy making a mistake and you're busy talking. That is the worst, you know, when you're talking and you're making a mistake. You're not even spotting the mistake, and it's just like, hey, it's sad, eh? It's painful, but it's not that painful really. It's just like, you know, it is what it is. Loan here was like, because I'm just putting this in the calculator, you know, loan was like 1,050,000 minus 419 and then 952.39. Yo, yeah, this person paid interest, yo. You see, I told you this was the worst deal ever, but like, what kind of a nonsense deal is this? These people. I don't mean to be mean, but like, bro, look at how much interest you're paying. You're paying whole 2 million interest, nje. Aye, man, you could have saved this money even, or something. But hey, let me not judge. I'm not a financial advisor. Anyways, that's the amount. Let us move on. Question number 9 here for 5 marks, ne? Whoa, bro, is that a 7? Hey, is this a 7 or a 2? Come on, bro. I don't remember, man. I don't remember. I don't remember, man. Like, I think it is it's a 2. Like, it has to be a 2. Anyways, let us do this thing here. This is a 2, right? Using first principles, they want you to work out this question. I mean, like, first principles is quite straightforward, you know. F prime is equal to lim h goes to 0, and then here you have f of x plus h. You have fx plus h, and then minus f of x, and then h over here, you see. So here, this is like lim h goes to 0. So where x is, you're going to need to throw x plus h. This is like 2x plus h squared, and then x plus h. And then minus f of x, right? So you have to put 2x squared here. What you got? It's like 2x squared minus 3x. The whole thing, let's put it over h. So let's do this. This is like lim h goes to 0. Here, if you multiply out everything, right, you're gonna have a 2 here. Then it's gonna be like x plus h, and then 3x minus, it's a minus, bro, minus 3h, please, thank you, and then negative 3h. This is like 2x squared plus 3x. Okay, let's see here. This 2 is outside still, you know. Let me just put here lim. So normally I like to do this step here on its own, you know, like this step on its own, but look at me being rebellious. Now look, so it's like 2 outside here. X times h is like x squared, and then x times h is like xh, but then that's gonna happen twice. So you're gonna have 2xh there, and then plus h squared. We just FOILed out this thing, you see. Don't worry, we didn't do any fancy business. We just FOILed out. And then all that being done, let's put this over h, and let's see here, lim h goes to 0. So here, let's see, you're gonna have 2x squared plus 4xh plus 2h minus 3x minus 3h plus this plus this. This whole thing here, you're gonna put it over h. And then let's see, you're gonna have this cancel that, this cancel that, so you're gonna end up with like lim, let's see here, lim whatever lim h goes to 0. This is like 4x h plus 2h minus 3h over h, and then you need to take everything out as a common. You have to take out h as a common factor, you see. Whew, the lim h goes to 0 part. Yeah, I know it's annoying, but hey, just gotta do it, you know. Gotta do what you gotta do. I feel like I forgot a squared somewhere, and I did. There, you forgot it. You forgotted it. So 1h is left in there. So here this is like -3. H is gone. Then you're gonna cancel the h at the top and at the bottom. So here you're gonna have f prime. This is equal to like that, because the moment there's only one h left here, you can just, let me actually not skip the step. Let's just keep writing the lim thing. I feel like I'm trying to run away from writing lim again. Like, oh, this thing is so annoying. So it's like 4x here plus 2h minus 3, right? So here you're gonna say therefore f prime is just equal to 4x minus 3. And there you go, there you go, there you go, 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 go. Okay, that's all. You can double check your answer by looking at this. 4x minus 3. Yep, 4x minus 3. Okay, 3 marks. They want you to differentiate. Yay. Okay, differentiating here. I don't think we are going to do anything extravagant here. Like, you know, it's all straightforward here. dy over dx. So dy over dx is what we are supposed to get, right? Let's see here. dy over dx. So this is going to be like 5 times 4, right? It's like 20. And then 4 times -6. What is 4 times -6? That's like -24, right? -24 to the power of 3. Like that, and then plus 3. Hi, man. This is a 4, my guy. Come on, man. Come on, bruh. Come on, man. Don't lose marks because of dumb mistakes, okay? So that's what we're gonna get here for 3 marks. Nothing crazy. Here, we need to simplify first, you see. So let's see, square brackets. There's a 3 here, ne? And then there's like a tiny 1 here. So the 3 goes under the 1. So it's like x, and there's 1 over 3 here over 2. At the top here is 1. At the bottom here is going to be like 9x squared. You see? And then what now? Here it's like dx. There's like 1 here and like 2 down here. So this is like 1 over 2 with x and a third over there. This can go up, so it's like 1 over 9 with x to the power of -2, like that. So here now, you can then say, now you can differentiate. You see, this times that is like 1 over 6 x. Removing 1 from here, you're going to get like -2 over x. And then this times this is going to give you -2 over 9. Removing 1 from there, that's like a -3. And here's your final answer, man. You know what I'm saying? I feel like I should double check my answers, you know? Just double check the answers, just to be sure. Because if you don't double check the answers, then how you gonna know? But it looks fine, you know? Question number 10. What they wanted, question number 10. They want 5 marks. I mean, no, we want 5 marks. So they said, this is the equation of the cubic function. This is a basic one, you know? Such a basic question. So yeah, as I'm looking at this paper, so far the verdict is that this paper was pretty straightforward. Nothing crazy here. They say the graph has turning points on the origin. And there's a turning point there, and there's an x-intercept over there. Then they said A is an x-intercept of h. Okay, show that A is -1 and B is like a 6. B is a 6, A is a -1. That shouldn't be too bad, because I'm like, we have a turning point, so we know that the gradient there is a 0, and we have a coordinate. So we can use the coordinate equation, which is like f of x, and then we can use the first derivative and the gradient. So yeah, that's how we're going to get A and B. So using the original equation, right, y is a 0, where x is also a 0. Oh, that's not working out, eh? Ooh, bombed out. Oopsie. Okay, let's use our first derivative first to get an equation with A and B. So with h of x, right, there is a x cubed plus bx squared. Let's differentiate this thing and equate it to 0. Differentiating this thing here, you're gonna have 3ax squared plus 2bx. Let's equate it to 0, right? You're gonna have 0 here is equal to 3ax squared plus 2bx. There you go. You have, like, you know, here you need to what? Well, the x value of the turning point is at, like, you know, oh, you're gonna use both of the x values of your turning point, because here the x value is a 0, here the x value is like a 4, you see. So you're gonna throw a 4 into the equation here, and a 0 as well. So here, oh, but if you throw a 0, it's also not working out. You see, now this is boring, man, huh? This is boring, Joe. Like, labora, Joe. But let's throw x as 4 first, then, and then work it out, and then make a plan, you know. If you don't make a plan, it's over. You must make a plan, man, you know. 16 times 3, or then that's like, I don't know, 48. Hey, bosso, don't do this mental math thing, okay? Leave this mental math thing alone. You know, you're gonna get hit, but it is 48. So, yeah. So it's 48a here. 8, 2 times 4 is like 8. So this is like 8b. So we have an equation in terms of a and b. Okay, so now I'm thinking to myself, how are we gonna get the other one now? Otherwise, dude, the coordinate, bruh. I'm being such a dunderhead here. I couldn't. I was busy thinking of this coordinate, but failing to see there's another coordinate over there, freely given, Joe. Bosso, it's freely given, Joe. It's given right here. Hey, anyways, y is 32, and then x is like a 4. So it's like a with a 4 there squared. No, cubed, bruh, cubed. And then what about the b value? The b value is whatever b value is. So let's do this here. It's like 2. So b is b. So it's like plus b. Then a 4 as well here. No, cubed, bruh, cubed. Come on, man. Don't make mistakes now, please. So 4 to the power of 3. It's like, what? Start 48. No, 32, bro. No, what? Yeah, don't use mental math, please. Just. So it's like 64. So it's like 64a plus 2b. What are you doing? It's differentiating. Hey, you know, sometimes in math, you do funny things and you're like, what did I just do? So here, what do I do here? There's a b here, there's a a there. Let's just maybe carry on here, isolate one variable and put it into the other one. Let's isolate b here. So it's going to be negative 48a, and then divided by 8 on both sides. You're going to have your b value is what now? Is it going to be a 6? Negative 6a. Let's see, 48 divided by 8. What is 48 divided by 8? It's like a 6, right? So it's like negative 6a. 48 divided by 8, that's like that. So this is b. Now, here we can throw b in there, you see. So it's like, let's carry on here. Let us carry on. 32 is equal to 64a plus 16. b here is like negative 6a. So this being negative 6a, you're going to have here 32 is equal to 64a. And then what is 16 times negative 3 now? 16 times negative 6, you mean? Times negative 6 is like negative 96. But let's see here. Negative 96. 96. A. Yeah. So this is like 32. 64 minus 96. What is 64 minus 96 now? 64 minus 96 is like negative 30. Negative 30. Oh, it's looking up. Oh, yes, nice. Negative 32 actually. Divide by 32 on both sides. A is a negative 1. And then therefore, -6 here with a as a -1. It's going to give you b. B is a 6. That's the way. I like it. So you see, all these things are like super easy, guys. Okay, if they're not super easy, then you must do yourself a favor. I even gave you a discount here, 50%. Is good, eh? Anyways, let's move on to the next question. Calculate the coordinates of A for 3 marks only. Where is A? Where are you? A is over there. A is an x-intercept. Well, we have the full equation of the graph, so it should be okay, h of x is equal to x cubed plus 6x squared plus 6x squared, right? Now they want us to get the intercept, so I mean, like, you can just factorize this thing here. There's like x here plus 6. X is equal to 0. I mean, x squared is equal to 0. That's going to give you this one. And then you can say, oh, x plus 6 is equal to 0. So here x is equal to -6. So you now know what a is. You see, a is like -6 coordinate 0, because this is one of the x-intercepts. And there's an x-intercept right over there, +6. Hi, bo, negative. Madam. Hi, man. When's in Johnny? Bro. Ish, now I need to check what I did wrong here. This, you're nah, manje. You see now. Oh, it's squared. Oh, but I took out the squared here now. This is not fair, man. Yeah, I don't know, line, it's not making sense, this thing. Like, it's like, but how? B6. Oh, a is a negative. Oh, I forgot to put a as a negative here. It's a negative over there. Negative. So it's like this becomes a negative. So this is a negative. And then this is a plus. Because if you divide by a negative on both sides, x is a 6. Whew, thank goodness. Anyways, let's move on. For 2 marks, they say write down the values of x for which h is increasing. Yeah, this is exactly what I'm like. It's on the main channel, these kinds of questions. Where's the graph increasing? Where's the graph of h increasing? So the graph of h, where is it increasing? A graph is always increasing where the y values are like going up. So from here, from this x value of 0 here until this x value of 4, you can see that the y values are going up. You see, everywhere else, you see they're going down like that, and then here it's going down like that. So here you're going to need to say that your graph is increasing from where x is an element of 0 until 4. That's why your graph is increasing. So yeah, anyways, now they're asking, where's the graph concaved down? Your graph is concaved down on the portion where it's like frowning. In terms of concavity, you always need the middle here first. The middle here is always the middle of your 2 turning points, you see. So the middle here is like a 2, because from 0 to 4 the middle is a 2. It's also your point of inflection. The x value is your point of inflection. You can get it by differentiating twice and equating to 0. You're going to get a 2. You either do that or you just get the middle of your 2 x values of your turning points. So this point here splits up concavity. You see, one side is concaved up because this side is like smiling. This side is concaved down because it's like frowning, So the part that's where x is bigger than 2, that's where the graph is concaved down. So here we can say x is bigger than 2. There you go. And then here for 3 marks, let's see. For which values of k will this equation have 1 negative and 2 distinct positive roots? Man, this is so annoying. Like, it really is, It really is. So what you need to understand is this minus x part, it tells you that graph moved 1 unit to the right. So the graph is moved 1 unit to the right first, right? The graph that we have, because remember h of x looks like this. Negative x cubed, and then what now? Negative x cubed plus 6x squared plus 6x squared. So you can see the resemblance, you see. Here they removed the graph to the left, and then the k is telling you that it's a shift from top to bottom, you see. It's a shift from top to bottom, vice versa. That's what k is. So what they're saying is, if you're looking at the image now, right, let me just draw the image here where we have it. Let me just try and replicate it here. We have our graph, it looks like this, you see, and then it goes like that. This is what h of x looks like. So they're saying this graph is moved to the left 1 unit, no, to the right actually 1 unit. So you move it to the right 1 unit, it would look like the following. Let's see here. If you move it to the right 1 unit, it would look like this, you see. This value here would be a positive 1 now. This new x-intercept here would be a positive 7 now. This x value of this turning point here would be like a positive 5 now. And then you can see there's one root and another root. So it's like 2 roots so far. So they said, for which values of k will this graph have 1 negative? One negative root and 2 distinct positive roots. So remember, k is moving the graph downwards. What you want to recognize is, if this graph is moved downwards, right, for it to have 2 x-intercepts that are positive, right, see 2 x-intercepts that are positive and then 1 that's a negative, you want to focus on, like, for example, your turning point here, right? If you're moving this graph downwards, you see, let's say you move it a little bit, you see, there's going to be a point where it has 1 x-intercept there, another one here. These are both zeros. I mean, these are both positive x-intercepts. And you see this one is having an x-intercept of like a 0. But then the moment you move it more than just this amount of units downwards, you see, you're going to see that it has 2 x-intercepts that are positives and then 1 that's a negative. You will keep on doing this all the way until your graph looks like this, you see, like this, you see, where it now only has 1 x-intercept and 1 is like a negative. So you want the sweet spot where it has 2 x-intercepts that are positive while 1 is a negative, because this will always happen depending on the amount of units that you move it up or down. So what you will note is, initially the way our question is set up, it's starting off with this image here. This image is clearly showing you that the y value up here is like, what is this y value? This y value here, it is, let's see it, it's like 32. You see the y value up there is like a 32. So that's what you have to remember. Up here, it's 32. Now the other thing you want to recognize is, you want to clearly remember, we said when this graph was moved downwards, you can move this graph downwards this distance here. You see, whatever this distance is, if you move it downwards that distance, anything above that distance, if you move it anything more than this distance, right, this is where you will start to have an x-intercept that's a negative while 2 of them are positive. So before we even do anything, we need this y-intercept over here, you see. Now this y-intercept over here, in terms of you like getting what this y-intercept is, it's not going to be too much of an issue, because the y-intercept here, remember, all you need to do is to remember that the graph of g was moved 1 unit to the right. So this graph of g being moved 1 unit to the right, you firstly want to find out what is its equation going to look like first. So g moved 1 to the right, it is going to be, as we said, negative x minus 1 cubed, and then you're going to have plus 6x minus 1. This is if it has just been moved to the right once. So you want to work out, where is this equal to 0? Like, where is the x value equal to 0? So you're going to put here 0 minus 1 cubed, and then 0 minus 1 squared. This is like negative 1 cubed, right? It's a negative 1, times it by negative, it's going to give you a plus. Negative 1 squared is a positive 1, and then this is plus 6, so it's like a 7. You see, the y-intercept is going to be a 7. Okay, let me just double check that I didn't make any funny business. I didn't. So the y-intercept is a 7. So this y-intercept being a 7, we know that this value here is a 7. So it looks as though the minimum distance that they can move it downwards is 7 units. They have to move it at least more than 7 units, but then they cannot exceed 32 units, because you saw that if you exceed 32 units, you won't have 2 positive roots and 1 negative one. So in terms of the answer that you're going to give, you're going to need to say the following. Firstly, remember k here. Don't forget that there's a negative sign here. So your graph can be moved downwards a maximum of 32 units. So you're going to need to say here k needs to be, yeah, this is where it gets a bit not too tricky. Remember there's a negative here. So if k is a negative number, it means that your graph will be moving upwards, you see. Of which, in our case here, for us to have the scenario that we spoke about, our graph has to move downwards, you see. So for it to move downwards a maximum of 32 units, you are going to need to say k has to be bigger than negative 32. You see, k has to be bigger than negative 32, and then k has to be smaller than negative 7. The reason why k has to be smaller than negative 7 and k has to be bigger than negative 32 is because, firstly, we said that for our scenario to like start playing out, you have to move it a minimum of 7 units downwards. So if k is smaller than negative hold on, bro, like don't confuse the people. I feel like I should say this again, you know. So we have to move it a minimum of 7 units downwards, you see. So if it's going to move a minimum of 7 units downwards, we're going to need to say k is smaller than negative 7, you see, because as long as k is smaller than negative 7, it means that the value you're going to put there will move your graph more than 7 units down, you see. So say k here is like a negative 8. If you throw a negative 8 there, it's going to be negative 8 times a negative, that's going to be a plus. So your graph would be moving upwards. Oh yeah, but then we need to move it down. So let's say k has to be bigger than positive 7, because if k is bigger than positive 7, it means that if k is like a 8, then it means you'd be moving your graph 8 units downwards. You see, if you move your graph 8 units downwards, it will look like this, you see, where it will have 2 x-intercepts here that are positive, and then one of them is like a negative over there. So you can move it as long as k is bigger than 7, it will qualify, but then k needs to be smaller than 32. You see, the reason why k needs to be no, dude, k needs to be smaller than 7, but k needs to be bigger than 32. The reason why k needs to be bigger than 32, what's the reason now? Hi, woman, this doesn't make any sense. K has to be smaller than 7. No, man, I'm sorry, I meant k has to be bigger than 7. Yeah, that's what I meant here. K, I feel like I'm confusing you, and I'm sorry. K here has to be bigger than 7. You see, the reason why k has to be bigger than 7 is because if you have a number here that's like 8, right, it means that you would be moving your graph, you would have moved your graph until it looks something like this, you see. That's to say k has to be bigger than 7, you see. We're using 8 as an example. Like a number that is bigger than 7 could be like an 8. So if k is an 8 over there, your graph would be moving downwards 8 units. If you move your graph 8 units downwards, it will have 1 x-intercept over there, and then 2 of them will be positive x-intercepts. You can keep doing that movement of going downwards all the way until you've moved it downwards 32 units. You see, so here you have to say k has to be bigger than 7, yes, but then k has to be smaller than 32. The reason why k has to be smaller than 32 is because you cannot move the graph downwards more than 32 units. Otherwise, as you saw, the turning point will be below the x-axis, and then you won't have your scenario of 1 negative root and then 2 positive ones. So with this explanation, you can already see it's crazy-ish. So this is definitely not the kind of question that everyone should think they need to like master or whatever, you see. Like don't stress yourself too much with these kinds of questions. It is not worth it. Choose peace. I mean, even you saw also as I was like explaining this what you may call this question, you see, it was crazy. You know, it was like, yo, what is going on? But it is what it is. It is what it is. Let me just move on to the next question. Anyways, so you have here the famous question number what? The famous question number 11 is what you have over here. So this famous question number 11 says the following. After traveling a distance of 20 kilometers from home, a person suddenly remembers that he did not close the tap in his garden. He decides to turn around immediately, blah, blah, blah. I did this question like the day this paper was written. I posted it on my IG page, by the way, on my math IG page. It's called at 0 aesthetics underscore. Yes, aesthetics is an E here. Underscore just mathematics. Okay. 0 aesthetics, just mathematics. So because of this, it says here, after traveling a distance of 20 kilometers from home, right? Traveled 20 kilometers from home, a person suddenly remembers that he did not close a tap in his garden. He decides to turn around immediately and return home to close the tap. The cost of water at the rate at which water is flowing out of the tap is 1 Rand 60 per hour. And then it says here the cost of petrol is this much per kilometer, where x is the average speed in kilometers per hour. And then it says here calculate the average speed at which the person must travel home to keep his cost as low as possible. So here them saying low as possible, you see, this should remind you of like minimum something. And then here they're asking for the average speed, you see, meaning you need calculate the average speed. Average speed here, they said it is x. Okay, calculate the average speed at which the cost will be as low as possible. So here the first thing is you need a cost equation, you see, and then because that cost equation, you need to know the average speed where the cost is a minimum. You need a cost equation, and then you need to differentiate it, and then after you differentiate it, you make it equal to 0. You see, that's the idea with all maximum and minimum kind of equations. Get an equation of whatever they're talking about, differentiate it, and then equate it to 0. So the cost of this whole scenario, right, is the petrol and the water. So you have to remember that for the petrol, remember they're talking about him going home only. So it's only a distance of 20 kilometers multiplied by the cost per kilometer. So the cost per kilometer, you're going to multiply it by 20 kilometers. So this is like the cost of the petrol. The cost of the water, you have to remember that it's going to cost him 1 Rand 60 per hour. So you want to think to yourself, if you think of the distance, time, and speed triangle. Remember distance, time, and speed. You have distance up here, time here, speed over there. They said his speed is x. So speed here is x. The distance is just 20. The time, you don't know, you see. So what you know is that the time that it's going to take him to get home is just 20 over x hours, you see. So water is costing him 1.6 rands per hour. So this is how many hours it's going to take to get home. So the rand of water per hour times the time that is going to take to get home, that's going to give you how much water is going to spend, or how much water, what his water charge is going to be. It's going to be 1.6 times the number of hours that it takes traveling, you know. because it's like 1.6 per hour. So remember, this is the number of hours taken traveling. So here, the cost of the water is going to be 1.6 for every hour that he'll be traveling. You see, this is your cost equation. This cost equation, you're going to just need to simplify it, differentiate it, and equate it to 0. So this cost equation is in terms of x. So before we differentiate it and everything like that, let's just simplify it. This is like 20. If you multiply the 20 inside, let's see what you're going to get there. 20 times 1.2, right? Let's see, 20 times 1.2, 20 times 1.2. That's like 24. So this is like 24x, no, 24 only, plus 20x over 4,000. And then this is like, what is 1.6 times 20 now? 1.6 times 20 times 20 is like 32 over x. So this is like 32 over x. And then what you get here now? This is like, let's see, this is c with x over here, c with x over there. Let's simplify. This is like 24. The 20 over 4,000, let's see what that gives us in the calculator. 20 over 4,000. 20 divided by 4,000. That's going to give you 1 over 200. So it's like x over 200 actually. X over 200. And then the x goes over here, so it's like 32 with like x to the power of -1, like that. Okay. This I can actually write it as 1 over 200 with x next to it actually. 1 over 200, x next to it. Now you have an equation that is easy to differentiate. So your first derivative here is going to be, this falls away. 1 times this is like 1 over 200. You're going to remove 1 from the x, so it's going to be x to the power of 0. You don't have to write anything here. -1 times 32, negative 32x, and then -2 there. So this is the differentiated equation as we said, you see. Get the cost equation, differentiate it, equate it to 0. Equating this to 0, let's see. 0 is equal to 1 over 200. 32x with the square funny thing there. 32x -2. So let's solve for x. Solving for x, the 32 can go over. This is like 1 over 200. And then the x -2 can go down. And then here, to solve for x, you can actually just cross multiply. I like to change color, you know, it feels good. So cross multiplying here, you're going to have x squared times 1 is like x squared. 200 times 32, it's what 200 times 32 is. It's going to be like 6,400. So 6,400, right? Let's see, you're going to have to square root both sides over here. So x under, always square rooting both sides. You're going to get a plus or a minus as an answer, you see. And then you're obviously going to choose a positive number because speed cannot be, you know, a negative. So this is just x is equal to 80. There you go. That's the way. I like it. This one was quite a crazy question, but it was okay. It is what it is, you know. Moving on to question number 12 for 1 mark. Question number 12 already. Is it the last thing? Oh my goodness. Sure, I didn't even notice, bruh. Wow, man. Wow, damn it. Anyways, it says for 1 mark here, A and B are independent events. Independent events mean that probability of A times the probability of B is just the probability of A and B. You see? And then they said here, you have the probability of A and B, check. The probability of B only, check. They said, are A and B mutually exclusive? No. These people. No, because the probability of A and B is not equal to 0. You see? But how do you know that now? I feel like I should be more meticulous. Meticulous. What does that word even mean? Okay, I should be more, like, you know, careful or whatever. But with mutually exclusive events, the probability of A and the probability of B is always equal to 0. So let's check this out. To get the probability of A, you can just use this formula because they say these are independent events anyways. So the probability of A you don't know, but the probability of B is 0.2. The probability of A and B is like 0.3. So I mean, like, the probability of A here, let's see, it's gonna be 0.3 divided by 0.2, right? So it's like probability of A over here. What is 0.3 over 0.2? Let's check it out. 0.3 divided by 0.2, that's like 3 over 2. So this is not equal to what am I saying? I didn't even have to work this out. I feel so dumb, you know. Don't even worry about working all this out. This is all nonsense. I should have just written what I wrote in the first place, because here, no, because the probability of A and B is not equal to 0. I was kind of distracted. I am so sorry. My head was somewhere else. So because this is not equal to 0, it means that you don't have mutually exclusive events. Let's see. Determine, because the thing is with mutually exclusive events, the probability of A and B has to be a 0 to say that they don't interact anyway. You see, that's for mutually exclusive events. But then here there is an interaction, so they are not mutually exclusive. Probability of A, we need to get the probability of A. We can just use the formula for independent events. Like, feel like I'm gonna do what I was just doing right now. Probability of A you don't have. Probability of B, you know, it's like 0.2. And then the probability of A and B, what is the probability of A and B? 0.3. And then I even had done it wrong. I put a times instead of a plus. You see, this is how you know I'm distracted, man. Or maybe I'm just hungry as well, you know. This goes over, you're gonna get 0.1. 4 marks. They are being generous here. And this probability section looks like it was pop and place. Yo. So they'll give you a mark for the formula. They give you a mark for subbing in. Correct answer. But 4 though. Also, that's too much, man. I think that's too much, me. No, I think it's too much. But why complain? The probability of not A or not B. Well, the first thing is not A. Let's get not A. So not A plus A. Remember, this is a 1. And then the probability of not B plus B, this is also a 1, because, you know, these are complementary events. They complement each other. So, I mean, like, all that being said, as we are saying it, whatever, you want to remember that the probability of A, we worked it out to be 0.1. So the probability of not A is just 0.9. Therefore, the probability of not A is equal to 0.9. With B, same idea. Probability of B here, what you get, it's like 0.3 is the probability of B. What is the probability of B now? 0.2, bruh. So let's see here. No. Yo. Let me wrap this out. I should actually be careful with these questions. I think I should actually look back at this question. Only A. Yeah, this is crazy. Eh? Only B. Okay, well, 12.1.1, I'm certain of it. But then why is this one being funny now in my head? A and B, only B. Okay, yeah, I think this one I should rethink it, especially since it's a formal question. The reason why I'm deciding to rethink this question is because I'm thinking of a Venn diagram. Because out of 4, I mean, like, you know, it's a lot of marks to just have done that. If you think of this Venn diagram, the one thing that you can recognize is that you have the probability of A on one side, you have the probability of B on the other side. This is probability of A, probability of B. They say the probability of A and B is like 0.2. So, I mean 0.3. This is 0.3 in the middle. And then here they say the probability of only B. So that's like only B. Only B refers to this part here only. You know, the part that is not including the A. They said only B here is 0.5. I mean 3. So it just means the probability of Hybo, man, bro, come on, focus, bruh. Probability of only B is 0.2. So meaning the probability of B is actually 0.5. So here, what else did they tell us? They said we should determine the probability of A. How? But then now, the probability of A is, oh man, come on, man, this is like hard. Is it really hard? So we have the probability of, we can just use the formula. Yeah, this is crazy. Oh, no. I can use the formula, yes, but I need to be careful because this is X, you see. So remember the probability of A, all in all, is, remember, this is the probability of A plus the probability of B. This is what equates to the probability of A and B. What you want to recognize is the probability of A is these two put together, you see. 0.3 plus X. That is the probability of A. The probability of B is these two put together. You see, that's like 0.5. And then the probability of A and B, that's like 0.3. So this equation here, you need to solve for X for you to get the probability of A alone. So this plus that is going to be like 0.8 plus the X. And then X alone. Whoa, come on, man. This is just buggered up. Man, this is not fair. Yeah, it really isn't fair because it's like, but then why is it not working out, man? Probability of A, probability of B, probability of A and B. Man. No, it's times, not plus. Oh, God. Excuse me. Yeah, I have a confession to make. As I'm like recording this, I know I have recorded for so many hours. Okay, not many hours, but like quite some time. I'm almost done now, and as you can see, I am like making again a lot of mistakes because yeah, this is really something I'm dealing with, but you know, it's gonna be alright. Anyways, let's just put the times over here in the middle. Let me remove this, and then let's just carry on. So carrying on, let's see here. You have to multiply inside. You see 0.3 times 0.5. What you're gonna get? 0.3 times 0.5. You're gonna get 0.15. 0.15. And then here 0.15x. Solving for x, you can take this to the other side. It's gonna be 0.5x equal to 0.3 minus 0.15. Let's see, 0.3 minus 0.15, what you got, 0.3 minus 0.15, that's like another 0.15, and then you need to divide both sides by 0.5. 0.5x, gonna divide this on this side, gonna divide this on the other side. Therefore, x is equal to what you get for x. It's like negative 1.5 divided by 0.5. I'm getting there 0.3. 0.3. Anyways, that's your value for x there. That's kind of weird though. Is it? Yeah. So your a only is 0.3. So therefore a only, or only a as they say it here, only a is 0.3. See, only a is equal to 0.3. So now we can work this out. Probability of not a or not b. Well, this Venn diagram can help us now. You see, probability of not a or not b. Well, let's just draw a Venn diagram, because our Venn diagram is complete now. You see, circle, Let me just delete this. Do that. No. Circle, circle. And then this is what? A circle. Okay, so the probability of not A or not B. Well, the probability of this thing, A alone, we got it to be 0.3. This was also like 0.3. This was 0.2. This was the probability of B. This was the probability of A. Now, with all this being done, they say the probability of not A or not B. Well, the thing is, what you want to do is use color. A Venn diagram always works if you have color. So the first thing is, let's use color for what is not A. So where is not A? Not A is everything outside of A. Like this is what not A is. This part that I've colored in yellow, that is not A. And then you want to ask yourself, what is not B? So not B is basically the red part. You see, everything that is, let me make it horizontal. Everything that is like not B, this is everything that is like not B. You see, everything that's in like red here, you see, that's everything that is not B. So where it says not A or not B, you basically need to take into account, oh, wait a minute, where it says not A, we colored everything that is in yellow. Where it says not B, we colored everything that is in red. So where it is not A, probability of not A or not B basically refers to taking everything together. Everything that is colored in green, everything that is colored in red together with everything that is colored in yellow. That's the part that's your answer. Because the rest is what's not your answer. You see this, if you look at in the middle here, this middle part is not colored at all, you see. So this is the part that this is the only part that does not qualify for not A or not B, you see, because the probability of not A, the portion that is not A, we colored it in yellow. The portion that is not B, we colored it in red. So O means you need to combine them, and that's your answer. So in our case, combining the yellows and the reds, the only thing that's left out is the 0.3 over there, of which you have to remember that the probability of everything here needs to add up to a 1. So if this is 0.3, this is 0.3, this is 0.6, plus this, that's a 0.8. Outside here, it's like 0.2. Everything needs to add up to a 1. So because everything adds up to 1, and this is the only part that is not included in your answer, it means that this answer here is going to be 1 minus 0.3, and your answer there is 0.7, because it's going to be this plus that plus this on the outside. That's the probability of not A or not B. That's where not A or not B intersect, if I can put it that way. So yeah, man, yeah, this is not too tricky. It's like moderate, it's like moderate, not too tricky. It is just moderate. But anyways, let me just move on. Let me just move on with the life, because let's see, what is this thing here? 12.2.1. 12. Okay, yeah, let's move on to the next question. Question number 1. We have question number 1 here. So question number 1, wait, 12.2.1. It says a teacher has 5 different poetry books. Much. And then 4 different dramas and 3 different novels. So how many books in total? 5, 9, 10, 11, 12. So 12 books in total. She has 12 books. Very interesting. Very nice, madam. Very nice. With these 12 books, she says, they say the following. She must arrange these 12 books from left to right on a shelf. Now, for 1 mark, they said write down the probability that a novel will be the first book placed on the shelf. So you have 12 slots, you see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They said work out the probability that the first book will be a novel. Yeah, work out the probability that a novel will be placed. A novel will be the first book placed on the shelf. So the probability of this being a novel, you have to ask yourself, how many novels are there? You have 3 different novels. So technically speaking, you can put one of 3 options here. The moment you have put one novel here, you have like 11 books to choose from. So here you can put one of 11 books, and then 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let me repeat. In the first slot here, you have to, if they're asking what is the probability that a novel will be the first book placed on the shelf, you ask yourself, how many novels are there? There are 3 novels. So one of 3 books can potentially go there. The moment you put one book here, you have 11 books to place. So one of 11 can go there. The moment you put one here, you have 10 options going on and on and on and on and on. So this here that we have gotten, this is the number of arrangements for the arrangements where your book will be a novel. Let's see what's the total here. And then we're going to need to put that over 12 factorial, and I'll mention why just now. So here, this number here, this answer here is like 11 factorial times 3. That's going to give you such a big number, bruh. How would you? What is this? Yo, it's a million something this 119,750,400. Okay, that is quite interesting. But yeah, man, that's the number of arrangements. But then the probability of that happening is going to be, firstly, without any restrictions, right? The number of ways you can arrange your books is 12 factorial. So 12 factorial is the number of arrangements without any restrictions. But then this number up here is the number of arrangements if your novel is starting. So that's your probability, you see. Your probability is always the total without any restrictions. That's going to be the denominator. The numerator is always going to be the scenario that satisfies the question that they're asking, you see. Write down the probability that a novel will be the first book. So you work out how many arrangements will the first book be a novel. You get that. You put it over all the possible arrangements. So the reason why all the possible arrangements is 12 factorial is because when you have no restrictions here, you know, depending on how you're going to put the books, you see, here you have 12 options, and then when you put one there, you have 11 going on and on and on and on and on. That's why it's like 12 factorial total options. But anyways, the probability here, if you simplify it, let us see what our calculator is going to give us. Let me grab my calculator here. 119,750 and then 400. There's like 12 shift factorial. Wait, man. Shift factorial, man. The final answer here is like 1/4. Wow, okay, that's weird. 1/4. Whew, okay, that's nice. The next one says for 2 marks, calculate the number of different ways these 12 books can be placed on the shelf, if any book can be placed in any position. Really? Calculate the number of different ways these 12 books can be placed on the shelf, if any book can be placed in any position. This is the dumbest question I've ever seen. How do you offer 2 marks for this question but offer 1 mark for the previous question? Come on, guys. No, fam. Nah. Hey, whoever set up this paper, ne? Hey, they were not thinking. I don't know, lie. I'm not even being mean right now, I'm just being honest. So let's see here, without any restrictions, it's just going to be 12 factorial, because you have you're gonna put one of 12 options here, then one of 11, going on and on and on and on and on. Maybe they just mixed these two up, let me not be so mean. Then the last question, oh thank goodness, for 4 marks here, it says, what did they say? Calculate the probability that a poetry book is placed in the first position. The 3 novels are placed next to each other, and the drama is placed in the last position. This is, here you have to be careful with this question, The first way to be careful is to draw out the 12 slots and then read the question again. You see 5, 6, 7, 8, 9, 10, 11, 12. You see there are 12 positions to put our books. They say it here, calculate the probability that a poetry book is placed in the first position, you see. So this first position has to be poetry. Okay. And then they say the 3 novels are placed next to each other. Okay, so all the novels have to be next to each other. So what you do is you just take any 3, you group them together. So you see these are the novels. You're just imagining a scenario right now. You see, they said here, probability that a poetry book is placed in the first position, check. The 3 novels are placed next to each other, check. And the 3 novels are placed next to each other, and a drama is placed in the last position. So in the last position here, they want you to put a drama book. Okay, drama, you see. So these are the 3 conditions. So what you want to recognize is, firstly, you have to remember that this kind of equation, you have to work it out, systematically. So the first thing is poetry books. How many poetry books do you have? You have, let's see here, how many poetry books do you have? How? Manje, who is it? 5 poetry books. So you have 5 options here. 1 of 5 can go there. So let's put a 5 in the front over there. And then what you want to recognize is at the back here. Let me actually do this. You have 5 options here now. 1 of 5 options. So let's put a 5 over there. And then at the back here, you have to remember they said a drama has to be put in the back here. So if a drama is going to be put in the back here, you have to ask yourself, how many drama books are there? You have 4 dramas. Okay, so you have 4 options in the back. These novels have to be stuck together. Now the idea is the number of arrangements, it is going to be 5 times, you have to remember that this is stuck together. So you have to think to yourself, when this is stuck together, this that is stuck together here, you have 3 objects in here. These 3 objects can be arranged in 3 factorial ways. So you put 3 factorial over there. And then what you have to recognize is that when one book is placed here, right, and one book has been placed over there, you have 10 options left. And then of those 10 options, 3 of them are gonna go here. So you only have 7 options left. So of the 7 options, you're gonna have to think to yourself, 1 of 7 is gonna go there, and then 1 of 6, 5, 4, 3, 2, 1. You see, 7, 6, 5, 4, 3, 2, and then 1 over there. At the back here, we said there are 4 options, you see. So don't take this for granted. You see, there's a 4 over there, and then there's a 5 in the front over here, and then there is a 3 in the middle here, you see. And then these numbers here, all these ones here, they are for the yellow. Let's say change style, yellow, done. There we go. Okay, so this is quite an intricate question. I'm not even gonna lie, this one is quite intricate. It is not normal. It is not your everyday question, you see. So this is the arrangements for the scenario that they gave us. Let's see what this number is going to be equal to. Let's get a calculator. So I need to get a calculator, but I don't have a calculator, so Let me see. I do have a calculator. What am I talking about? Like, I definitely have a calculator, you know? Like, I don't even know why I'm saying I don't have a calculator. But anyways, let me see here. Give me a calculator. So if I'm gonna get a calculator here, it's gonna be 5 times 3 shift factorial, and then times 7 factorial in the middle over there, and then times 4. 5 times 3 factorial times 7 factorial times 4, that's like 604,800. 604,800. So the probability of this happening is going to be 604,800 over all possible outcomes. You see, therefore probability is going to be 604,800, the whole thing over 12 factorial. So let's see here. 604,800 divided by 12 shift factorial. So this is like 1 over 792. 1 over 792. 1 over 792. So I can tell you this up front. Okay, I didn't tell you up front. Well, I'm telling you now. This question was not very normal, you know. It was not very normal. It was not your everyday question. It was difficult, you know. This last question here, you know. So if this is the kind of question that you can see is not your cup of tea, don't worry about it, you know. Do not worry about it, you know. Rest. But anyways, that's that. Let me just double check this question again, you know. Calculate the probability that a poetry book is placed in the first position. So you have 1 of 5 options there. The 3 novels are placed next to each other. Oh, snap. Nah. I think I need to do one last thing, actually. Because these novels are not just going to be stuck over here. These novels can move. So because these novels can move, I actually... This is going to be quite crazy. I actually have to multiply this whole thing by... what do I have to multiply it? I have to multiply it by... Let me actually pause and think. Oh yeah, I have to multiply it by 1, 2, 3, 4, 5. No. I have to multiply it by 1, 2, 3, 4, 5, 6, 7, 8 factorial. The reason I have to multiply it with 8 factorial is because these novels here are not stuck in the front. You see, these novels can be anywhere in between any of these, you see. So here I have to multiply this by 8 factorial. And then this, let me just change it. Yeah, man. Yeah, this question is crazy. It's like super duper crazy. But anyways, if you disagree and you find anything fishy, I mean, like, I'm just a human being, man. Like, you know, like, I'm doing this before the official memo. But I can guarantee you that a good 90-something% of all this is like 100% okay. You know, because obviously there is maybe like a dumb error I made somewhere. I didn't see it, you know. I mean, like, that definitely always happens. But if you spot anything funny, just let me know. This doesn't work out. No, man. Come on, bro. Hey, let me pause again and think. Okay. I think I get it now. This middle part is what I need to correct. So the reason why I need to correct the middle part is because you see in the middle, right? If you look at the middle on its own, you technically have 1, 2, 3, 4, 5, 6, 7, 8 objects, right? That can be arranged in 8 factorial ways. And then these can be arranged in 3 factorial ways, you see. So 1, 2, 3, 4, 5, 6, 7, 8 objects. They can be arranged in 8 factorial ways times these objects that can be arranged in 3 factorial ways. You see, that's for the middle. You see, the entire middle is going to be 3 factorial for these 3 objects multiplied by 1, 2, 3, 4, 5, 6, 7, 8 objects, you see. Okay, that's much better, much better. 5 times 3 shift factorial times 8 shift factorial times 4. This is equal to 4 million something 4 million 838 400. There we go. So you're going to divide this by 12 factorial. Divided by 12 shift factorial. That's like 1/99. What a wow, bro. Yeah, ne? Hey, yeah, this is the answers that I'm getting. Remember, I'm recording this, as of this recording, it's like the 9th of November. So a good 90 something percent of this is 100% correct. And then I'll put in the pinned comments any funny errors or whatever. So if you find out anything is a bit shaky, just point it out and let me know. You can hit me up on IG, and then I will definitely be able to, like, fix it up at LE. And you can just leave a comment. I always read the comments, and as of this recording I have a lot of comments to get to. So hey, it is what it is. Thank you very much for watching, or thank yourself for watching, because you've been putting in the work. So don't forget to subscribe and share this with your friends, and like tell them that this channel does past papers, blah blah blah. But obviously from this, I mean, like, the idea is you're gonna need to, like, if you're really serious about your math marks, just enroll yourself onto the course platform. There's a discount code. It's BYB50 at checkout, and you're gonna get 50% off absolutely everything. Everything. So there we go. So good. Ciao, ciao, ciao.